Hello, everyone. How are you doing today? Alrighty. So today we're gonna try to make a game as quick as we can using Naylib, which is nim bindings for Raylib. And yeah, let me kind of share what I would like to do. Because I gave it a little bit of thought, not a lot, but a little bit of thought, and I think I came up with an idea of something that we can start implementing feature by feature, where it will get progressively more fun, hopefully. So, bam, there we go. So the idea is that we have a game where a player controls a frog on some kind of grid system. You can move up, down, left, right, okay? No big deal here. So that's our first goal, to have a grid. We can move up and down and whatnot. Then we have a situation where time progresses as player jumps. This is basically in a way that I would like it to be a little bit like Crypt of a Necrodancer, where there's a constant beat in a game, and as the player jumps in a beat, I don't know, things work out. If the player doesn't jump, the beat still happens, but maybe things slow down a little bit. I don't know. Something of that sort. Maybe the slow progression at some point. For now, it will be like, you jump, there's beat, whatever. On the bottom of the map, there's a pond, and your goal as a player is to protect it. Then the player has some kind of wetness bar. When it reaches 0, the player dies. So basically, you need to stay wet, and to stay wet, you need to get into the pond from time to time. Okay. Similarly, we have a hunger bar, so we need to eat flies from time to time. You can shoot your tongue to grab a fly. Then we can another thing to do in a game will be that slowly, I guess from top to bottom, various pieces of trash will be showing up, and probably with a rhythm of some kind of pattern, just coming down towards the pond. And the goal is not to let it reach to the pond, because if too much trash gets in there, you can't get into the pond and can't get, can't maintain the moisture. And then a player can push the trash off the map to get rid of it. And the whole idea is that the player can use their tongue to either bring the trash just one tile closer to you, or you can use your legs, which you can kick with your legs from the opposite direction from the player's back to push the trash. We'll see how many number of blocks away from you. So that's how you'll basically kick it off basically the grid. And that's it. You play until you die, and maybe the game gets faster or something. We'll start with absolutely no graphics. We'll just draw some rectangles. I have a few ideas of what it could look like, but we just have 5 hours, so we don't have that much time. So let's start off by making a repository. Let's make it pond defense. Okay. A simple 2D game where you're a frog trying to defend your pond. Period. Okay. Make it public. We'll add readme so we have it all done. Git ignore for nim. Do we have something here? There we go. And license will be MIT, because this is what we're doing on the streams. So let's create a repo. And let's clone it. Just give me a second. I'll do it off screen. Pond defense, clone. Okay, we've got the repo cloned. Cool. So, I can open it up. Okay. Pawn defense. There we go. Open VS Code. There we go. This should be enough. In the meantime, I also have our previous live stream here. Okay. Where we can grab this code. I was playing around with it a few times to just have an idea of what we can even do, but haven't had that much time. Oh, I could probably just copy the whole thing, right? Let's see what we have here. Stream 2? What's this? Basic window. I have no idea what I was doing here. Because we have two versions of the same thing. So let's do this. I'm gonna just initialize the new thing. It wasn't that much work, right? So let's see, we'll refresh it. So the idea was that we do nimble init. Okay, this will be a binary. Sure, description doesn't matter right now. We don't have time for that. Okay, sure, the latest nim version. And we need to do nimble. I think we just go here. There we go. And that requires Naylib. Was it Naylib? Yes, and I think we have a newer version of it as well. I think 5.15 was released like a few days ago. So let's try to do that. We'll save it, nimble install, and see if it works. Okay, we got something. And we have our pawn defense.nim. Let's replace it with our code from here and see if it runs. Save it. Nimble run. Whoop. Open for a split second. Right, we don't have the rabbit. Okay. Sure. But it started up. It compiled, so we should be good. So let's clean it up a little bit because we're on the clock. So we're gonna leave all that standard math. I'm gonna leave that random. I don't want right now. So we have our template for game setup, game loop, update, and draw. And the initialize. And I believe at some point I made a converter from vector 2 to vector 3. I'm just gonna grab all this code. I'll do include utils, and we're just gonna make new file, utils, and we're just gonna shove all those things here. Just simple include so that, you know, I don't know if we need this or not. And definitely not .nim. Okay, cool. That should be it. And let's see if we can clean up. Screen width and all that. Let's do window name, pawn defense. We don't need max bonies or batch elements. All that is unnecessary. All this goes away. So, we've got a game. For some reason, something tells me nim will have more problems. Because no matter what, after the update to 208 and updating the VS Code extension for nim, and then updating the basically Nimble and Nimlang server, things keep breaking even more. Okay, so game setup. We don't load any textures right now. None of those. We don't do any randomize. Although, you know what? Let's keep the randomize here. I'll just do, you know, and more stuff. And we're gonna have that math and random. There we go. And this should work, hopefully. Okay. So we've got all those things. Why is it complaining about all this? Did we put it in the wrong place? No. Go figure. Maybe after we compile. Okay. And then an update. We have if this is down, if this and that. We'll get to that. This will be our for now we're just gonna discard it so that it doesn't complain. And we have our draw, which sure, background, and then draw stuff. And we're gonna keep the draw FPS because I kind of like it. Okay. Oh, whoa. Errors disappeared. What the hell happened? Do we actually have some kind of success? Alrighty. So if I run this, it should just start, right? Hopefully. Just wide window with FPS. Yes. All right. Now we're talking. So we have our thing set up. Okay, we're 13 minutes into the live stream. We might get somewhere. So let's just make a quick task list. What I would like to do. To do or something? Yeah, to do. So first to do will be draw frog code and draw grid code. Then will be draw frog on a grid, move around the grid, you know, keep position somewhere, and then we'll be add bounds to the grid. So these will be our first steps. Okay. After that, when we already have the grid, we should probably do add the pond. Then will be probably something like draw the pond. Add moisture meter. Add moisture drain and add moisture refill. Okay. And let's see how fast we can get there. So first let's do draw frog code, okay? So for now we're just gonna make the frog just a circle with 2 eyes and maybe 2 legs or something. So let's figure that out. Let's just define an extra constant, which will be maybe grid screen size or screen width. Let's do tile size and let's make it 64 pixels. We can make it extra large for now, okay? Sure. Sure, that's good enough. 64 pixels. So maybe I can make new file frog or how could I call it? Render .nim, okay? And we're gonna do it real simple. Again, just an include so that we don't need to worry about imports. That will help us doing things quickly. So here I would like a proc draw frog, okay? And we'll need a position as a vector. Rotation, we'll probably make it a direction. And then we're gonna have scale, nope. Color, no. Just that. Maybe in the future we're gonna add state what the frog is doing or some kind of animation system. I don't know yet. But we need the direction and we need the other stuff. So let's add yet another file. common.nym, and we're just gonna make type direction, which would be an enum, and we just have up, down, left, right. That's it. Okay. So let's have it here as well. Before it, include common, maybe even before the utils. Okay. Save that, and let's see if we can do something here. So for the frog, we have this constant here. Let's actually take it out of here and let's define it in the renderer. Okay. So this would be the size. Sure. I'm gonna make another utility for converting a vector2 into something like that will work with integers or whatever. So let's do something like type and call it vector2i. Perfect. And that will be a tuple that has x and y as integers. Okay. And on that type, we can basically make it so that proc because I would like to be able to convert to and from the other vector, a normal vector, quickly without doing a lot of code. So let's make it procedure to int, and I will take normal vector and turn it into this one just by doing this. We'll see if we need some kind of different integer, but for now this should be fine. Should be fine. Object constructor need an object type. Tuple declared. Oh yeah, we just do this. There we go. While if we do proc to float, we convert the other way around, and we're just gonna do vector to bam. Okay. This should help us a lot. And this isn't happy for some reason. Undeclared. Okay, that's strange. For now, let's just plop it here. We should get somewhere to something working. So let's even say that we just define it on this kind of vector. So at a position, and now we need to start drawing. So how do I draw a circle? Draw. Something tells me this will work really badly here. Because here I'll probably have available all the, draw this, draw that, draw circle. Okay. And we have either center this or center that. So to draw circle, we have here and here, and what else do we have in here? Radius and color. All right. Sure. So we're gonna do the radius will be, we can just cut it off here, plop here, draw circle. We basically position to, because now we need to do the offset. Okay, so let's do it like this. But position is position to float. Yeah, let's just grab this float. We'll just, I don't know. What will be operating with? All the logic will be operating on integers, right? So let's just keep this as integers and we'll do the conversions here. So we're just gonna do this. Yeah, to float should be fine. Has no type. How does it have no type? It has type. Okay, and we'll do plus, and hopefully we have the vector math here, right? Plus this. So let's do const half tile size, and we can just reuse it everywhere. It'll be a little bit easier. Okay. To float. Yeah, to float on vector 2i. I mean, we're not even exporting it anywhere, so we shouldn't worry about it. Okay. So got this. We draw the circle in basically this position with the size of being tile size minus maybe 4 pixels or something. And do we have green or something? I just want to see if I can, I know, draw a basic circle. This should be here. So let's go back to our code and just draw frog. And our position will be here as in, sure, screen width divided by 2. And this by 2 as well. And we don't do it into float. There we go. And rotation will be north or like up. That should be enough for now. Let's see if this even compiles or I'm doing something inherently wrong. 2916. Oh, because that tuple obviously is always like that. Then we've got render name underscore identifier vec2. Oh, vector 2. Sure, that should be good enough. Please work. No. Technical routine vector 2. Are we not importing the renderer? We have that renderer here. So what is the problem? How do I make a vector 2? Do we make vector 2 somewhere here? Vector 3. Sure, that worked. This is a vector 2. And we create it. Oh, I see. Because this is not a constructor, that means we need to actually say that this is X and this is Y. All right, that should improve things a little bit, but I don't know if to the point that we can actually run it. Mismatch got vector 2 for add to float position. What expected float? What? To float. Oh, system.nym. Oops. Okay. I guess it's decided on system.nym rather than our utility. Ay. 2F. Let's do 2I. Okay, this should be a little bit more obvious. These should work. Don't know why it shows up in red for what reason. but it should work, hopefully. Please work. And therefore we do 2 to F. Get vector 2, but expect the float. I guess there's no math for defined for adding floats. We have very math. We were doing that, right? There was no problem. Why do I have it defined as float? That's the problem. AI is trying to compromise the work. Okay, so it works. We just have the NIM tooling totally not cooperating. Okay, so we've got that. And I guess this is supposed to be radius. Yeah, so radius needs to be half tile size. Bam. Okay. Additionally, we can draw maybe 2 eyes or something. Draw circle. It'll be position plus x. Let's do x something like -5. This will be depending on the orientation, right? But let's just do -5. And let's -10. Something like this. And let's see what happens. Half size tile. No, these will be tiny. Eyes will be tiny. Let's do 8 pixels. And let's do white. One will be here. The other one will be here. Let's see what happens. Got the eyes down there. Okay. So that means let's make it actually plus. Position. How the hell do we do that? This code, run it again. I want to make sure that it actually shows up. Look at that. Eyes are all the way down there now. So what do we need to do? Position. X1 is fine. Let's just do... Yeah, because we're doing offset of the center, right? So -10, -20, sure. Okay, let's do that. Let's just add the black dots for eyes. So let's do, let pulse left will be our left position will be this, okay? So this will be eye left position, and then we're gonna do another one, the same position, which will be maybe like 4, and let's do black. And then we're gonna do the same thing here. Okay. So it'll be eye right position and this. And what does it look like now? Okay, we've got eyes. Let's call it progress, okay? Sure. Oh, that's so silly. Let's call it A for now, okay? We've got the frog. We just need to add direction. So let's do it in a way that we always draw eyes the same way, right? We just need the positions to be calculated. So that's the only thing that we need to vary. So let's do case rotation. Wow, what the hell is this? Let's do I left position will be just position here, and we'll just start it with that and then modify them further here. So, although I don't know if we have plus equals here. Left position. Can we do that? And we don't get any errors showing up here, so that should be fine. Has no type, ambiguous. How does it have no type? Sure. So we've got this. We've got this, which is wrong. There we go. And the other one, right position will be this. Is that correct? Let's call it correct. So we basically copy everything here. Paste, paste, and paste. What's the problem with that? It has type here. Go figure. All right, so let me think. For down, we'll need to kind of swap those eyes just in case we're doing them. Just in case they have actual purpose. Okay. And instead of going this direction, we're gonna go there, and then for left and right, we'll see. How can I check the rotation? We could quickly probably just make it so that for a number of frames, it shows one direction, the other number of frames, it shows some other direction, and we'll just keep going that way. So let's try to do that. Let's do this here. Frames left to rotation will be, I don't know, 60. We'll just do every second, okay? Okay. In the game loop, we'll just make it plus minus equals 1. And then if frames count rotation is 0, then we're gonna set it to this. And rotation is, yeah, we need to hold rotation as well. Up. Okay, let's do direction dot up. Okay. So that means the rotation is here, and we can basically increase it, but then we're gonna get an error, right? Cardinality. So let's do direction dot cardinality. That should tell us how many elements there are in that specific enumeration. So in this case, it'll be 1, 2, 3, 4. So we'll do rotation plus 1. And we do what, percentage for mod? Or was it mod? I think mod is for that. I guess that should be enough. hopefully. Rotation is supposed to be direction. I don't know if it's going to convert it for number automatically or not, but we'll see. Yeah, and that's an update. So an update, we just set the rotation, right? Yeah. Okay. And that's it. Well, when we draw it in a rotation, or let's just call it frog direction, okay? Frog direction. That makes a little bit more sense. Frog direction is this. And bam. Okay, that looks good. Sure. Let's see how badly it fails. Okay. Top mismatch. Frog direction. Oh, so we basically need to convert it back to direction, right? Sure, let's see if that works. Card. Really? How did one check cardinality? I guess let's reach into documentation as always. Or in this case, I can just use Claude for quicker results instead of searching for it all. Nim. How can I check cardinality of an enum? Okay, while it thinks, do we get any other errors? I don't think so. So maybe with the render, I'm gonna figure out how to draw the other eyes. So wait, this was down. Oh, okay. So this is down. Left will be minus 20 and minus 20 here. The left eye will be minus 10. Well, this eye will be 10. Probably the other way around, right? Doesn't matter right now, but that's that. And the right one will be 20 and 20, while the left one will be negative 10, and this one will be 10. And maybe that's enough. Just maybe that's enough. What the hell out hell? So did we get an answer? We have high and low. But convert these to ordinal values. I thought that was cardinality. I'm sure there is cardinality, but for some reason it's not showing up. So let's do high minus low. So high of direction minus low direction, or in our case, we can just do high of the direction plus 1. Right? Yeah. That should make it work. Hopefully, no more errors. Bam, one more error. Type mismatch. Ooh. It's your lateral. Well. Oh. There we go. Pardon me, Nim. Oh, thinking more. Start it up. And up, down, left, right. Up, down, left, right. Okay, we've got the frog working. The only thing I don't like now is that it should be up, right, down, left. Okay, this is a bit nicer. And this way we can rearrange this up, right, down, left. There we go. So let's run it again. And we should see the frog rotating slowly to the right. There we go. Okay. I know it's tiny, but we're gonna get there to make it work a little bit nicer. All right, so let's check our first box off. Okay. We have code for drawing the frog. Now let's have code for drawing a simple grid. So let's go to our renderer and we're gonna do proc draw grid ground. Look at that. That's gonna be nice. So we're gonna do start position. Yeah, that'll be top left corner, and then we're gonna have size and tiles. Okay, and that'll be it for now. So what can we do here? So I just want to draw a bunch of rectangles. Okay, so we're gonna do for X in start position. No. From size for basically I want to go from 0 to less than size and tiles dot x. This way we can iterate over all of them. The same thing here. Y will be increasing, so we'll be going without the 0, 0 is in top left, which I have no idea where I'm even pointing at. But all right, probably here, because I believe you can see me as a reflection. No, you can see me normally, so it'll be here. No, for you it'll be here. Yeah. Okay, so let's do draw rectangle, I think. Because again, tooling doesn't help. Draw rectangle. And what is that draw rectangle? Do we have any items here? Rectangle. So we have position and size and color. Sure. So let's do position will be, oh yeah, now will be position will be the starting position. Okay. And to I2. No, to F2. Okay. So we have the float normal vector. We add the vector of this time tile size, this time tile size. Sure. That works for me. Sure. That should work. Figure this out partially. Interesting. Wow. Undeclared field. Dot. All right. So this should be the position. So we just make it position and then let's just make it like plus maybe 2 pixels to the right and here or something. Sure. And then we've got a size or something. Yeah, size in pixels, I presume. Okay, so the size will be 10 Tile size -4, and the same thing here, and the ground will be also green. Great. For now. So that should draw the whole grid. Therefore, I can do first draw the grid, ground. So let's do this. Starting position will be, I don't know, 200 pixels or something. 200, 200, okay? And then size and tiles will be 10 by 10, okay? And I think that's all we need to give it for now. Yeah, let's see if that works. Undeclared field to F2. Really? Worked here. Why doesn't it work here? Oh, because... Oh yeah, that's actually a good point. We could make it like this. Sure. Now, but expected float 32, and that's in here. Oh, I see. So this should be a float 32. And this and that. Oh, so basically it expects a float 32, but we're giving it... so how about that? I'm just gonna do this. To F2. And that should solve the problem. Or not. We have X, now we have Y. I don't think we can do that. All right, vector 2. Wrap it. And hope for the best. And the same problem will be down here, right? Gray with A. Oh, leftover drawer rectangle. Okay, we got a grid. That was truly painful, but at least we've got some kind of grid and a rotating frog. So now the goal will be to keep track of the position of the frog, and then basically be able to move it around, okay? So check out that we have the grid. Now, draw a frog on a grid. Okay. So in our variables here, we have frog direction. So let's do var frog position. And that will be the vector to I. And we're gonna start by 0, 0. That will be the first position, okay? So while we have this, instead of drawing the frog here, because now we'll need to start converting from our coordinate system to the screen system. So maybe we can make a simple utility for it here. Like under this, we're gonna make it proc to screen coordinates we'll take this vector and return the other vector. Yeah, maybe we'll actually make it that everything that's being drawn on screen will be just normal vectors, while whatever's in our logic, we'll use those integer vectors, okay? So we're gonna take this and we're gonna create a new vector. We take the x from position. And here, yeah, here we would basically need to do times tile size, and we also need like the initial spot. So let's do grid origin. Vector 2, and sure, let's just do it 200 by 200 for now, okay? Just for now. And this doesn't complain about it being integers. Go figure. Nothing wants to cooperate. Okay. So we'll basically do grid origin plus this. Let's just do normal return or whatever. Okay. Grid origin plus this, and it should get us to where we have to be, I think. So that means that our draw ground will be at the grid origin. Screen space, okay. Let's have it that way, just so we're for sure. Okay, screen space, and then we've got the size of the grid. Well, draw the frog will be frog position to screen coordinates, and let's see if it works. Mismatch, mismatch, mismatch. Really? Oh, because now we changed it around and we want the draw frog to just use this one so that we don't have to do any of this. Okay, sure. And then the same thing here where we don't have to do this. I will just rename it like this. And size and tiles. Sure, that can stay. Okay. Will it start now? Okay, it started now. Got a frog center on the first tile. Okay, this is progress. Okay, not bad. So now move around the grid. So we basically need to add our arrows to work, right? Go up, down, left, right. So this should be actually one of the simpler things. So in our update, for now we have just frames left to rotation, so the automatic rotation will get there. And the direction. So this will, let's do it auto rotate the frog, okay? After that, let's do handle user input. Let's actually move it all the way to the top, okay? Because we want to handle the user input as soon as possible. So whatever calculations we're making, they're happening already on, you know, on up-to-date inputs. Okay, so let's do if key pressed is up. You're gonna make it that you have to press that many times to go up. You're not just holding the key, okay? So this is, we're gonna do it in two phases too. So if the key is pressed up, then we're gonna do frog position dot y is, yeah, decrease it by 1. It's down as this, left and right. I think that should be enough to actually move the, the frog around. Let's see if that actually is gonna work. Key. Oh yeah, we don't want a key or something. Hopefully it's not gonna be confused now. Please don't be confused. And there we go. We can move out of the grid. That's not a problem yet. But hey, we've got that. So I wanted to do something else with the movement, okay? The thing that I want to do with the movement is that the frog will be rotating towards in a direction that you're moving to. But if, let's say, the frog is facing up and you press the right arrow, the frog won't just go to the right and start facing there. First it's gonna face there, and then you're gonna press another key, then it's gonna actually move. And this is so that we can stand in one spot and rotate the frog wherever we want. So let's get rid of this weird timer here. Okay, no more auto-rotating the frog. So when we press up, we'll do if frog direction is not up, we'll just make it up. Otherwise, we're gonna move it up, okay? And I believe we can do something similar here, and AI will just do it for us, okay? So we don't have to just do the repetitive stuff. Let's see if it works. Oh, I have some... No, I might have it. Okay. I pressed the right. See? Down, left, right, left, up, down, 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 down. So I can move around and then just go in a direction that I want. This will help us, let's say, position ourselves somewhere. And then, I don't know, press spacebar to shoot our tongue at something, okay? Okay, this is getting simpler than I expected. This is way simpler than I expected. But one thing that I'm going to change is let's make the background black, because the white is probably blinding for some of you. Where do we have it set? Draw. Let's do black. Okay, and this will let us see the frog a little bit better too, I believe. There we go. Okay, cool. So this works. Oh, I can hit just escape. Awesome. Bam. So let's just add bounce to the grid, and I'm gonna upload the code. You know, it will be our first checkpoint. So for now, when we're drawing the ground, we just said that, okay, this is the size of the area is just 10 by 10. So let's make it a part of game setup. Hello, CPN, how are you doing? So let's make it grid size, sure. No, grid size sounds like, let's do map size, okay? I'll be vector I, and let's make it, X will be 20, Y will be 20 as well. Let's make it maybe 30 for Y. I don't know if we can actually fit that much on a screen, but we can change that the Y of this is just something. You know what? Let's just move this to be constant so far. At this moment, at least. Let's say that map size is this, and then we can basically calculate where's the center spot or whatever. So for X, it will be 20 times... let's actually do it this way. Map size dot X. We divide it by 2, okay? And we just do, yeah, because it will be, yeah, times tile size. There we go. So Y will be Oh. So this is basically where the left spot is compared to the screen size. So let's do screen width by 2. And we're gonna do minus this. So this will be our x coordinate. I know it's not very readable. But that's how the game stuff is sometimes. Carlos Fernandez is asking, Nim? Yes, it's Nim. Recently, Nim feels a little bit like going the masochist way. Okay, screen height, and let's hope that AI got it right. Probably it is something simple. Sure. So, given we have the map size and the grid origin screen space is already defined as well, we should be able to just plug the map size to here. Map size, okay? And this will show a little bit nicer map, and I hope it's gonna be centered directly in the center of the thingy. Looks like it's centered, and we are, yeah, the screen isn't large enough for this size. So let's make it maybe Y will be 20 and X will be something like 16 or something. This should fit. CPN says, who cares about readability when it just works? Yeah, the just works part doesn't work for me recently. Okay, I guess we won't fit that much. Come on. I don't want to worry about scrolling or something, or, oh, there we go. Now we have a nice grid, okay? Oh yeah, I think this will be plenty enough room to play around with the game. Sure. Okay. So now let's restrict our frog from going out of the grid. Okay. So to do that, we can basically add a check. Now, where do we want to add that check? Because we have those here. So in theory, we could just add those checks directly here. Or we could have a separate one for checking the location. But I think I'm going to just add them here because we're already checking, like this is the only situation where the frog will actually move up. We don't want ever to be the player to be moved, at least not now. So face up if it's not facing, else if frog position is 0, or if it's larger than 0, then decrease it. Otherwise, don't do anything. There we go. So we're gonna do the same thing here. If we're going down, if it's map size y minus 1, then just gonna do this, and for the x is gonna be as simple as before. And I'm seeing I'm making a silly thing. There we go. Else if. Okay, this looks better. And we can remove one indentation level for all of those. Okay. Okay, I can live with that. CPN is asking, what is this game about? So now that we have actually some viewers, let me go quickly over the idea. So the idea is that we have a game where we can control a frog on some kind of grid system that you can already see. Player can move around, and the idea will be that just like in something like Crypt of the Necrodancer, type progresses only when the player moves, so you can think ahead and has a little bit of strategy style thing. Then on the bottom of the map there will be a pond that your role is to protect, because you're a frog, you protect your pond. Then you have some kind of moisture stat or whatever. It just constantly decreases unless you're inside water. Therefore, in a pond, you recharge. So from time to time, you need to return to the pond, or you're gonna dry out. And you also need to eat. So there's another hunger bar. So you need to eat flies. So that's the the distractions. But then the idea is that there's a bunch of trash from time to time spawning on top of the map and just slowly going down in some various patterns. Different kinds of trash will, move in a different pattern. So when the trash goes in the pond, it blocks some area of the pond, therefore you can't get in there. And therefore, when trash clogs the whole pond, you can't get wet in the morning, you die. And you can push the trash of the map to the left or to the right by kicking it with your legs from behind. And you can also use your tongue to kind of move something towards you if you need to rearrange things. And that's pretty much it. And a feature could be, some kind of, with some kind of beat, something going on, where it could be something more fun. So that's what I came up with when scratching my head. What can I make quickly that isn't like a Pong clone or another clone of something that's already out there? I'm sure there's something like this out there already, but I don't know, this felt a little more unique, a little more fun to code. So let's do the thing. This should already restrict the movement around the grid, right? Let's see if it works. So I'm pressing left and I can go. I can rotate in a direction, but I can go there. I go here and can go out. Can go to there. Oh gosh, there's lots of pressing to move fast. It might be actually needing a smaller map at some point. We'll see. Okay. Sure, another checkbox. So let's commit the code, okay? We're gonna go here. And we're gonna do not .exe. Sure. All this. And let's make it draw, frog, and grid. Allow movement within. Okay. There we go. I can actually quickly copy the repo wherever it's at. If somebody at some point wants to grab it, it's on YouTube, it's on Twitch, and I'm gonna add it to the description. Let's just add emoji of a game or whatever. Let's do game, code, GitHub, repo, and paste the link and save. There we go. Million places for the link in case somebody wants it. Alrighty, so now the goal is to actually draw the pond. And to draw the pond, if we're gonna, where is it? Where did you go, code? Here. So let's just run the game. So I would like the pond to be literally maybe the center tiles on the bottom, or maybe all the tiles on the bottom. Sure, all the tiles on the bottom will be the pond. Okay. So I guess we could just draw them in a different color, and that's it. And for now at least, because at some point we can add, hand-drawn graphics or pixel art or whatever, but that would take me way too long, I presume. So for now in our renderer, when we hit draw ground, we'll do those things, okay? But then let's do -1. And the last thing that we're gonna go over, will basically position X stays the same as here. Y will be Size and tiles Y. There we go. -1, of course. We need to decrease it. And this will be blue. Do we have blue color available in Raylib or something? Yes, we have. Okay, we just drew the pond. Oh, this feels so wrong going in such a shoddy way. I'm not used to it. Usually I'm just stuck being perfectionist. But hey, time limit actually works. All right. So now we're going into UI. We need to add moisture meter. So let's make something like simple proc draw meter. Sure. So we're gonna do position. Let's do screen position. Let's do screen bounds. And we'll just make it rectangle. And value will be something. Max value will be something. And let's add color. Okay. So let's think. We have bar width and all that. Let's just draw a rectangle first. So draw rectangle. No weird lines. We start screen bound X and Y, width and height. I can probably just plop screen bounds here, right? And color will be we need a border, so let's say that for now will be white. If the background is black, we're just gonna make it white for now. And then inside of that, we'll draw another rectangle, which will be red or something. Or let's do it black, okay? In the background, and this will be basically screen bounds X +1, and sure, hopefully it's gonna work. I'm already complaining about something. It wants to be float 32 or something. When we have draw rectangle, we have this. Other than that, everything needs to be in 32. While the rectangle is probably floats. That's why. So int 32, I think. Yeah. There you go. There you go. And there you go. And there you go. Nice and ugly long line. But it should work. So this should draw like a bounding box. So let's maybe plop it there already and see what it looks like. Let's just go top left or something. So this is that, and so let's make it draw world, and here will be draw UI. What do we call it? Draw meter. Draw meter, and rectangle will be 10 from both edges of the top left of the screen. So for you from here, and then with sure 200 height will be 10. And let's just make it, I don't know, out of 0.5 out of 1. Okay. And we're gonna make it red or something. Right now it won't show any progress or anything. It should be just a like white little thingy. There we go. It's there in a corner. Can I move the FPS? Yes. So let's do screen width. Mine is something like 100, and maybe that's gonna work. Please work. Uh-oh. Okay. The thingy locked itself again. We need to wait for the app to just stop executing, because sometimes I notice with Nim, it just, oh, now it just stopped. You close the window and it just is stuck doing something. Oh, still not. Huh. Very interesting. Oh. There we go. So let's run it again and we should see, yeah, there we go, a box. If we change the screen background, it will just still have black background. This is good enough for now. Although I might just make it a little bit larger, right? Sure. Let's make the meter 20 in this direction and maybe 250 in that one. In the renderer, we can make the whole thing a little bit thicker. Very funny. 4 and 4. There we go. And then we just need to draw whatever's in the middle, the progress bar. So you can notice that we have the value and then we have the max value, okay? So we would basically need to normalize the both so that max value is a number from 0 to 1. While value will be the proportion of it or whatever. So let's say we do scale the value, the max value to the 0, 1 range. So like calculate the scale. The multiplier to scale the max value to 1. Okay. So the scale will be, yeah, we just divided the other way around, okay? And therefore, calculate the scale, I'll scale the value. So now we can just do the value times the scale. So at this point, we already know that this will be 0 to the max value, where max value is always 1. We'll ignore edge cases like, you know, what if the max value is negative or something? Let's trust ourselves a little bit here, okay? Now it will be easy to actually figure out how to fill that meter, because we can just calculate what's the width, we multiply it by the scale, by the scale value, and we're just gonna always have the filled area. So we can do basically so let's get this number and have it as a constant or something, like constant border width will be 2. And we're gonna do basically, where we have +2, we're gonna do plus border width. We can probably prettify it a little bit here. I hope Nim allows for that. It should, right? I can't see why it wouldn't. Okay, and a black at the end. So we're just gonna do minus border width times 2. And that means that here we can reuse that border value. So let's do, let bar width will be screen bounds width. So basically what width of the rectangle we wanted minus twice the border width. Okay. So we remove the border so we always show things accurately. And we're just gonna do the scale. Okay. So we can just do times value. Okay. And what I would like to do is not convert it to, because this is float. Let's make it float as well. And this whole thing times the value, and sure, that'll be it. And when just drawing it, we're gonna do it properly. So we draw the rectangle from the X and Y to bar width. We converted the proper value. This will be the same thing as somewhere else, and we specify the color that we passed as the value. And this should, in theory, be a complete bar. So right now we have it set to have value 0.5 from the whole one. So it should show up as half filled. And there we go, we have half filled. If we're gonna make it that the max value is 2, well, this will be just a quarter of the whole thing. So let's see if the scaling works. It does not. Why not? Come on. Yep, it does not update. Okay. Really? Oh, I'm probably using value instead of the scale value, right? Something real simple. Where was it? Down here. See? Scale value needs to be here. Okay? I know that this could be simplified into one nice short and tidy string or something, but I just wanted explained and I didn't want to think, so adding comments, let AI help me out. Okay? I wonder if it's like linear interpolation or something. I don't know. Okay, now it's correct. See? Now it's correct. Cool. So, all right. So we're gonna meter. So now we just need to make it a moisture meter. I'll ignore the idea that preferably it will be a nice little water icon or something. But for now, we're just gonna make it blue. Okay. Blue. That'll be our meter for moisture. And then we're gonna have another meter that will be for hunger, which orange maybe? I don't know why orange came to mind. Maybe yellow. That will be more fun. Okay. So when I run it again, oh, maybe not yet. Oh, look at that. It's still, again, kind of crashed in the background during turning off. So we need to move the other one. If the first one is 20 plus 10, it'll be 30. Let's do 40. And we should have 2 meters looking relatively okay. So yeah, so we need to add the backing field for it, as a C-sharper would say. So let's do, oh, this round only turned on. We can see we have 2 fields, okay? I mean 2 meters. So now let's do var frog moisture, which will start with, I don't know, for some reason I like just a nice number, and var frog hunger. Let's do, oops, how do you pronounce it? Satiety? Oh, I don't know how to pronounce it now. Unsatiable. I need to know how to pronounce it. Where's the thingy? Google Translate. That's my way too. Whatever. German. Okay, let me turn on the volume. Desktop audio. What does it sound like?
Satiety.
Satiety.
Satiety. Sättigung.
Satiety. Go figure. I would not come up with that pronunciation. All right. So we've got our fog satiety and moisture. Let's say max is 1.0 and the same thing here. All right. Therefore, we can plug in, we can just define those that it's 1.0, whatever. And this will be frog moisture. And we're gonna do frog satiety here. And they should be nice full bars. There we go, 2 full bars. Okay, so we actually checked off 2 boxes right now, I believe. Moisture meter. Okay. And add hunger meter. Add hunger drain. And add hunger refill. Okay. So now the moisture drain. The way I would like the moisture to work is that every time player moves, including rotation, you know, a little bit of time passes. Therefore, the moisture just slowly goes down. You know, if you would develop the game, you could have a game mode where maybe the moisture, you know, the sun is full and moisture goes down fast or something. The one thing. Well, for hunger, I want it to drain less with rotations. Or, yeah, let's keep it the same. Rotations and movements to keep it simple. But also when doing special actions like kicking and using your tongue, that will probably use extra hunger, okay? So let's do the moisture drain first. So we have all those moves here, okay? Each one of those is a player input, therefore it should be considered a move. So how do we do that? How do we... and I would also do it else if, because if we're gonna check for up, we don't need to check for down and all that. I know it's, you know, not the best option, but still. So, else, look at that. We can do, if none of those happened, we can do, so let's do, let player moved. Let's assume it's true. While if none of those happened, we're just gonna set it to false. There we go. We inverted something, so we don't need to cover it in all those scenarios. All right, so we know if the player moved. So now we can basically do something like if player moved, we're gonna do frog moisture minus equals, and let's do moisture loss. Sure. So let's define moisture loss. By being constants, we're gonna do moisture loss is 0.04 or something, okay? And we're just gonna do hunger satiety movement cost, okay? And that will be movement cost will be something less. Kick cost, let's do it maybe something like this, and lick cost will be 0.04. Let's make it something like 6. Sure. These are minute numbers for now. We'll be able to balance it over time. But for now, if the player moved, we do this, and satiety, the movement cost. So it should be actually decreasing as we move, as the player presses buttons. Be assigned to... Oh, bar. There we go. Alrighty. So we can see that right now there's no loss. I move to the right. Boop. There we go. Moisture goes down. Bum, 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 bum. While the hunger increases. Wow, that's interesting. What? Oh, minus. There we go. That was funny. So the whole idea is that the moisture, wow, I can barely get to the pond. That will definitely need to be decreased. They seem like tiny numbers, but wow. Okay. So sure, we've got a loss. So let's do the drain. We won't add the moisture refill yet. And the same with hunger. Let's do first add death from moisture / hunger. Okay. Sure, we'll just plop it here. So it'll be nice to just add some kind of game over screen and wait to restart just for now so something is happening, okay? So what we can do here is add a simple flag. Is frog dead? And it'll be false. So let's start with true, okay? It'll be our starting screen for now. We can always flip it to just start the game immediately or something. I don't know. We'll see. But we start with the frog is dead, and therefore, let's do it this way. If is frog dead, well then, do we want to do something? So let's, because there's so many things like we could just put that away as a separate process input. But then we have it tied to this, and depending on the action, let's just leave it the way it is. So is frog dead, then we're just gonna do return. Wait, because these are templates, no, this is a bad idea. Huh. Well, let's just skip this whole thing and just print out that, you know, if when we have a draw, when we're drawing, if is frog dead, we're just gonna do sure. You died, and we want to add a button, so we draw button, restart, and we're just gonna make it if it's pressed. Then we're gonna set the frog position here, direction up, sure. We reset everything and set that the frog dead is false, okay? So we need to implement a quick drop button, which should be relatively simple, okay? So we can probably copy our draw meter because this is very similar. So let's do draw button. Let's make it also that has the bounds, okay? Then we're gonna have something like text, should be string. We don't need any colors, but it will return bool if it was clicked, okay? So let's skip the whole border thing here. What we're gonna do is we're gonna draw the rectangle as background. The background will be, sure, let's say, sure, white, whatever. Dark. Let's do dark gray, okay? Oh, this will be the border, so yeah, black. And then this will be the fill. So we're just gonna +1 -2, and this will be light gray with time. So let's do if is mouse button pressed, is mouse button down. Okay, when the button is because we want the button to highlight when we hover over it and react when we click to it. So let's maybe do the hover thing first before we even draw anything. So type button state. Okay, normal hover and clicked. Perfect. That's all we need. So we're gonna define the state. Normally the state is normal, but if if now we just need the mouse location, right? So let mouse position is get mouse position. That should give it to us, right? So mouse position inside. We don't have such fantasy tools, right? So let's just say let is in bounds. Okay. So we're gonna make some comparisons. If the mouse position dot x is larger or equal to bounds x and less than equals to bounds x plus width. Okay. Oof, this is gonna be painful. This and this, I guess the and could go at the end. Let's just continue here. And mouse Y is this and that. Yeah, that's good enough. So we know if the mouse is in bounds. So if it's in bounds, that means it's hovered. So let's do is hovered. Okay. So now we can do if is hovered and is, let's do if is mouse button down. Okay. Or is it pressed? Because when we there's let's do released. Because we want to click the button after we release the thing. I guess that's like a good practice for this kind of immediate GUI. This way you can hold the button, and you know what? I decided not to move it off the button and release, and then it's gonna go, oof, I didn't click it by accident. I mean, it doesn't matter with restart, but still. And when that release is not happening when the button is down anymore. So these are two separate periods of time. So that will be clicked. Else we'll have it hover. Okay. So this way we have our state, and based on that state, we can basically decide how to draw it. So let's do it. Okay, let's make it let BG color is case state. If it's normal, we just make it light gray. If it's hover, it will be white. If it's clicked, it will be, I don't know, yellow or something. It just stand out. So that will be it. And we can just plop it here. And then the other thing will be draw text. And do we have a description of text? Draw text. Not texture, I want text. There we go. So give it text, position X and Y, font size, and color. Okay. So we're gonna make it real simple. Bound X plus 10, bounds Y plus 10. Let's now do bound height. Is it? Oh, I'm modifying the wrong spot, am I? No, I'm doing it. Okay, okay. Why do I have scaling here? Oh, because that was for the meters. Okay, we don't care about that. Oof, for a second I thought I just started modifying the meter and screwed everything up. How's everyone doing, by the way? There's not a lot of chatting today. Okay. Draw the text. Text. We had the bounds for the X, and for Y, we're gonna have the same thing, but for the height, I want it differently. Isn't height? It is height. Sure. Integer 32 divided by, or converted to by something. Times 0.8. Sure. This way the text will kind of scale. Let's do it 5. And therefore, we're gonna do this minus 10 times nothing else. Sure. And this will be the text color. And for the text color, for normal will be sure black, and this will be black as well. I guess no big deal here. Dark? No. We'll have it in it for the future use. Sure. Let's see. And then at the end, I mean, we can just do it here. If the button is clicked, we can also say result is true, because by default it's false, and nim already created this variable for us behind the scenes. We can just assign it here and not worry where we're returning. When we get to the end, we just return it and we should be fine. We should be fine. Let's see if this whole bunch of code actually works. So if the frog is dead, we just do you died. We do the bounds, which will be not like this. Basically will be rectangle, right? X will be screen height by 2 minus 100. Sure. Y will be, wait, this will need to be width. So let's do that. This will be bam bam. Height will be maybe something like 30. Sure. And width, I mean, that will be definitely more than that. So let's do 200. Width will be 400. And that's it. And else we draw everything. So the moment we die, everything else disappears. Because why not? But we still want to draw the FPS at the end. Okay. Let's see if it works, because I'm sure it won't. Type mismatch, of course. Draw text. Text bounds, this and that. Expected for the first one to be either font or this or C string. Do we need to convert it explicitly to C string or something? That's the conversion is supposed to be implicit. These need to be integer 32, so let's just make sure that we don't have anything screwed up here. Here. Bounds x plus 10. Dot and 32. Dot and 32. And maybe now. Oh. There we go, play again. And when we hover over it, it shows up and we click on it. Oh, instant click. So it didn't wait for the release. So that's one bug that we have. We can simply make it so that when we draw it, this is just for drawing, okay? And at the end, we can just do if is mouse button released. Okay, the same thing. Only then we actually mark it as that. Okay, cool. And that should fix the problem. So we are here. If you died on the left. So when I click on it, it's yellow. When I move away and, you know, I'm clicking, I can hold it and move away. But when I hold it and then release, there we go. We're in a game. So everything works. Okay. So now we just need to make it so that every time we change some of those meters, and one of them goes to 0, we just make the frog die. Where was it? We're in wrong place. So here is that. And at the end of those updates, let's make it if frog moisture is less than 0, frog is dead. If frog satiety goes to 0, frog is dead. And start. And therefore now we can just do this. And I'll just keep rotating. Okay. And you died. Perfect. We've got death. Big win. Sure. So now the easy part will be add moisture refill. Gosh, it's nearly, what, 2 hours of making it? Holy moly. The time flies fast, but we're moving fast too. We're starting to get something going. So the moisture refill is basically, after this whole movement is applied, we want to do if player, frog position dot y is equal to map size 1 minus 1. So basically, if frog is in the pond. What? Not that. If the frog is in the pond, refill moisture. We'll just set it to 1 instantly, okay? You don't have to wait in the pond. You just go in there, dunk, and you're good to go. So, I mean, that should be it. That should be the whole refill. But it already, that simple thing forces us to go down, okay? And just dunk yourself, and you can keep going. Normally, we will be dead already. Perfect. And then we died of hunger. Okay, cool. Let me just change one thing. So I would like there to be var frog start position. And I would like it to be maybe in the pond itself. So the y would be map size this thing. And this will be map size dot x divided by 2. And let's just make sure that it doesn't turn into an into something float and 32 or integer. There we go. Sure. Therefore, frog position will be the frog start position initially. Even though we don't worry about it yet because when we restart the game, we need to set it. So here. If this happens, the frog position will be the start position, and we'll be facing up, which is fine. Okay, let's see if we have that going. Okay, play again. Yeah, we started from a good spot. So let's just move around to die and play again, and we're back in the pond. Cool. All right, that's good. So got our moisture refill. Now will be the difficult part because we need to add the hunger refill. And how do you refill your... Let's do satiety, okay? What a strange word. So the idea is that you can eat a fly and that will let you survive a bit longer. So to make that possible, we need to A, have a fly, and then B, we also need to be able to eat the fly, which means we need to shoot our tongue to some direction. So this is where fun begins. So let's just make a simple code for drawing a fly. That's gonna be really simple. Why not just call it health? Because you're not really getting injured, right? We just need to fill up your food, and code is just satiety. I know, I like to name things appropriately. While in a game, we can imagine that there's just, you know, an icon of a fly or something. You need to keep eating flies. So let's do proc draw fly. And it needs to be position, and we don't care about fly's rotation. Fly will be just fly moving around. We don't care. For some reason, I'm anal about, you know, naming things in some way. I spend way too much time on that. But that makes me happy. So let's think about how to make a fly. For a fly, we're just gonna make a little rectangle and few circles for the wings, and we'll call it a day. Okay, so let's draw a circle. It will be position minus something like x will be maybe -5, -5, sure. Size will be 10, white. And let's just start making that fly show up somewhere on one random tile, all the way from the beginning so that we can see it. So we have the draw frog. Let's make the frog appear over the fly. No, the other way around, because the fly can go fly over us. It's because I don't want a collision with the fly. I imagine that it's possible for the fly to just fly over you, and why not? So but we draw fly. It will be the, I don't know, fly position for now. And yeah, that's it. So let's add fly position to our variables. This is starting to get hard to manage. So this is all frog, okay? So then let's do var fly position. We're just gonna make it, I don't know, 5 for now. We'll show up there, and let's see if we have little tiny white circles somewhere there. Ooh, a correct object construction syntax. Really? Oh, of course it is wrong. Okay, we've got a fly in this weird spot here, but we can correct that. So we just need to make sure that, just like with the frog, we correct the position to the center of the tile, okay? We can even make it proc to tile center, okay? Just take the vector 2, and we'll just correct it. Bam. To tile center. There we go. Sure, let's put this here so it looks pretty. So we're gonna start the same way here. And we'll just do this. And I want to see what it looks like. Okay, we've got this little thing. Sure. So that's... How is that -x? That doesn't make any sense. Half tile size, half tile size. Oh, because I'm subtracting. Okay, plus, sure. So let's do 4 of them. So v plus, this one will be like this one will be like this, and this one will be without any of them. So we should have 4 little white circles, and I just want to see how close they are together. Okay, that's good enough, and we can just draw a rectangle in the middle. Draw rectangle, which will be position X minus, let's do 3 or even 2. We just need to make sure that this is in 32. So that's where we start at the X. Then we're gonna have Y, let's do -4. And then it's the size, so be 4 and 8. Black. And let's just see if this looks remotely like a fly. But again, wow, that's a tiny rectangle. Let's do it 3, will be 6, and let's do it. Oh, this will be 6. Well, here we're gonna do, sure, 6, 12. I should probably do something like 7, 14. And here will be 4 and 8, whatever. And this should make the rectangle center a bit larger. So we have something fly-like. Okay, we're getting there. 9, 18. Or let's just go for 10. Why not? No, 18. Still needs to be fly-like. Bam. Okay, this is our fly. Very high fidelity fly. Wow. I should probably make it faster if I would just make pixel art and load it, but I don't want to waste time on figuring out how to do that, because that's where time goes. So we can draw a fly, okay? Sure. There you go. 11 and 22. Okay, cool. I'm leaving it now. Okay, so we've got our fly, and now the idea is that we want the fly. I wonder, what should I do first? No, let's leave the fly where it is. Now I want to be able to, you know, shoot the tongue to try to catch something. Sure. Let's see what it looks like. What we can do with it. I mean, at this point, we suddenly need a way to animate something to actually take time. Because we need a little bit for the tongue to fly out and come back. We're gonna leave it for now that when you press the button, it just shoots out and stays there. When you release the button, it comes back. For now. Just so I don't have to deal with animations. Because animations will mean an overhaul. So when we have draw frog right here, we should also be able to draw a tongue for the frog. Let's make it for now just a rectangle that goes somewhere. But we also need to basically specify from where to where. So we have here draw frog, so let's draw fly. Let's do something like draw tongue. From position. Okay. That's the start position, which will be vector 2 on screen, and then it will be direction. And then length and tiles. So we'll be able to specify how long the tongue is, because I would like the tongue to maybe reach 2-3 tiles in front of you. Okay. So the position will be, of course, the center. Then what? The center of the tongue will be under the frog, so we don't worry about it. It is where it is. We just need to kind of calculate the size of it. So let's do bounds for now is, didn't we have like draw line or something? Line. Draw line 3D. Wow, so many. Image draw line. Draw line, there we go. Start position. XY, end position XY, color. But do we have like a width or something? No, we don't have width. That sucks. So let's just go with a simple rectangle. Sure. Okay, so bounds will be rectangle. For now empty, and then we do case direction. So if it's up, we want the rectangle to be the position X, and let's just do something like constant tongue width, which will be just, I don't know, 4. Half tongue width. There we go. Let's make it, yeah, 4 is fine. So we're just gonna do this. So the X will be the position. Because up, we're not moving it left or right much, so no lengthened tiles. We'll just do minus something like half. Tongue width. Okay. Why is it complaining about everything right now? Seriously? This looks good. This looks good. Let's just make sure this is an int 32. Okay. So we've got this guy. Y position will be just the Y position, because that's start position. Or is it? I'll be the top. Yeah, because the rectangle will be on the top. So let's do position Y minus length in tiles times tile size. Okay. We'll see what it looks like. We'll make adjustments afterwards. So that's that. Width will be straight up tongue width, and height will be length in tiles times tile size, and that's it. So that's for up. Let's just underscore. We'll just make something, whatever. And therefore, at the end, we can just do draw rectangle. Bounds, and let's make it red. And that should be it, hopefully, to draw a tongue. So start position, direction, and length in tiles. Sure. Or is tongue open? Sure. Let's start with true for now. It'll be just sticking out. And var tongue length is, let's make it 3 tiles, okay? And tongue direction will be up for now. So this is the tongue, and let's draw it. So we'll draw it before the frog, so it shows up from under it. And draw tongue. So tongue will start from the frog position, the screen coordinates, and tongue direction and tongue length. And we'll make it if tongue open is tongue open. Only then we're gonna draw it. Hopefully. Is tongue open? Yeah. Let's see what kind of errors we're gonna get. Expression expected but found keyword constant. Really? What else do you want? Okay, this is a little bit confusing. Oh, because I didn't say that it's a proc. There we go. That makes it a little bit more obvious what the problem was. Still don't understand why this is all just like weird. Okay, let symbol requires initialization. Really? I mean, it should figure out that I'm setting it everywhere, unless that was an experimental flag or something. This match got integer 32, expected float, and that's here. Oh, because bounds actually expected to be a nice fun thing. Sure. And hopefully that's gonna figure itself out. Let's see. Let's see if that works. Nope. Still the same thing. So these will be floats, but this isn't aware that it should be a float. So we're gonna do the same thing here, and maybe it's gonna work. Please work. No, of course not. So it's unhappy about position 1. Oh, come on. Pretty please. Length and tiles. Special identifier is ignored in declarations and cannot be used. How the hell did we define the default case? How do you define a default case in case statements? It should be faster now. Should be. It's interesting because sometimes it's just faster to use the AI to ask a simple question than go to search for a documentation or something, especially with language like that. Oh, it was just else. Okay. Totally forgot about that. Oh, that works. Let's see what happens. We've got a tongue, and it's 1, 2, 3 tiles. Exactly. So if I was here, I would grab the fly. Awesome. Okay, that's a success. It was actually going a good direction. Let's just put a cherry on top and make it tip position, which would be vector 2. So not top position, tip. Tip position will be what? Position X, yeah. And Y will be this minus that. And yeah, that's it. So we'll go up. Now let's go to the right. Ugh, this is gonna be tough. So let's actually ignore this part. CPN says the tongue turns into a tail when the frog goes down. Yep. Now interesting, a frog with a tail. Yeah, we're gonna add stream number 30 of making the game will be adding a mutation system where you can mutate your frog to have a tail. Alrighty, so when we're looking right, starting position will be the X. That's fine. No minuses. Dot float 32. Okay. Now Y will be sure, that's good. Width will be length and tiles, time tile size, good. And the height will be good. And therefore tip position looks great. Down and left, maybe it's gonna work. We're gonna see. We don't need the else statement now. Let's just do draw circle at the tip. Where did that come from? The allocate. What? Draw circle. There we go. The allocate. Sure, 4. There we go. So let's see if we can run it. Okay, we can run it. That's good so far. And we can move around, but our tongue doesn't move with us. At least doesn't face in the direction we want. So for now, we can just make it that the tongue will be the frog direction. I mean, in theory, it should always be the frog direction, right? Because we don't want the frog to shoot sideways. What just happened? Mismatch. Draw tongue. Oh, here, frog direction. Okay, so let's see. That's good. Left, oops. Right is good. Down might be good. Down is good. Just left is all wonky. Okay, we can fix that. At least AI took care of down for us. So left will be, this is correct. Y will be this, which is correct. Then width will be times, no, it'll be length. And tiles, well, this will be width. Sure. And here we just need to correct it to make it that, sure. Okay, that's good. Yeah, look at that. And we died. Dried out. Okay, so we've got the tongue drawing. What if I'm gonna change the tongue length to something shorter? So tongue direction, let's just scrap that variable. We don't need it. Tongue length, let's make it 1. It'll be just the next tile, hopefully. Yep, that's good. Okay, so looks like that works. So we can basically specify the tongue length, if it's open or not, then it's gonna draw it. And now we just need to make it show up when we press a button. So let's make it maybe left control. I don't know how, because you move with arrows. Space, I would like to be a kick. While Z maybe or something. Hello, drunk alcoholic. Cool, an encoded game. Yeah. We're using the language for that. I can see lots of progress being made with also bindings to Godot. Like bunch of comments every day. Alright, so let's figure out. Let's make it, I know, Z or something. So this is if the player moved, okay? Therefore, the moisture loss, or whatever, of movement. Now let's do if is key pressed, and it will be the, what do you call it? Z. Okay, if we actually press down the Z, let's make it is tongue open. It's gonna be true. And then we're gonna do to do calculate possible length. Okay. And then we're gonna do what? Leave it open. Okay. Else if is key released. Z. When we release it, then we're gonna do, hide the tongue. And that's that. We can just test it if it runs. Also, when we open it, I want to do something like, what is it? Frog satiety. Lick cost, okay. Let's just see what it looks like when we run it. Because the other thing will be when we have that key pressed, we don't want any other keys to be processed. Okay, so we can move Z, 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 Z. And therefore it'll be Z, Z, Z to, in our case, not just lick the fly, but eat it. Okay, so that part works. Let's just make sure we don't start with the tongue sticking out. And we can probably move this thing to something up here. Bum, 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 bum. Probably not even here. Okay, something like this. Let's just put it up here so that we have the tongue processed instantly. So let's do licking, and then will be to do kicking, and then we've got movement. And for all those to work, I would like to make it only if the tongue is not sticking out. A frog licking game? Yeah, it's a quick explanation. We'll make a game where we can move a frog on a grid system. Time will move, the game progresses only when you actually jump. On the bottom map, on the bottom of the map is a pond, the blue tiles that we can get into to get moist again. And when you dry out, you die. And and then you also will need to eat flies with your tongue to sustain yourself, to not die from hunger. And then later we're going to implement that there's trash going down from the top of the map. I need to keep pushing it out to the sides so it doesn't land in your pond and block it so you won't dry out. Okay. And that's it. All right, so for now we have all this. Let's indent this whole thing. Besides this, if is tongue open, like not open, okay, Otherwise, we're gonna make the player move false because they just couldn't move. So let's make it block movement when tongue is open. Okay, and let's see if that works. Okay, we play again. I can move. I hold Z to hold the tongue open, and I can't move anymore, okay? And bam. Okay, great. So now what we need to do is basically check the distance to, you know, if the tiles in front are available, and if there's a fly, to just eat it and add some, you know, reset the hunger meter or something. We just make it that it completely resets it. So let's make it this way. Instead of having fly position, let's make it var fly positions. Okay, because we might have multiple, which will be a sequence of those vectors. And we're just gonna wow, okay. Start with 2 of them. Why not? Okay. Perfect. So we get rid of this one. And here, when we're drawing the fly, we just do for fly position and fly positions. We just draw the fly. So we're gonna draw, you know, paint multiples of them if necessary and whatnot. So now we have this one to do. Calculate possible length. So we'll basically need to check if the, you know, from the position of the frog, we move in a good direction. Is the fly there or is there not? And keep extending up to the maximum tongue length. So we could do let's make it variable. Max tongue length, and will be 3 for now. Okay. So let's think about it. Calculate possible length. So we're gonna do current length is 1 because we start check from the length of the tongue 1. And basically, current check position is the frog position plus, let's do the frog direction to offset, okay? And let's actually do it here. We have a command and we can make proc to offset on the direction, and that will turn it into a vector. Up will basically change this. That's it. Okay, it will just make it into a vector so that we can move it around to offset. Oh no. Now we're getting into a problem with not being able to do the math with those guys. This shouldn't be in utilities in the first place. This should be in common. So let's move it to common. We've got direction. Before that, we're gonna make it into this thing. In 32, because everything else operates on N32 for now. Cool. So we have to offset, which is the vector 2, and then we can convert it to the other one. Cool. Sure, whatever. So currently check position. Refrog position plus this. Let me just do the plus thing. It shouldn't take too long, right? Not utilities, common. Okay. So let's make this very simple thing. Proc plus from vector I with offset with vector 2. There we go. So from this one plus this one to in32, that's good. And we can do another proc plus, which will be vector 2i to vector 2i. And that should be it. Now we can just do the last one, which will be vector 2 plus offset as vector 2i. And that should be in vector 2. And that should save us some time in the future. So for now, this should be enough. And here we can suddenly take a frog position, add this as an offset. And to offset, I would like to actually return vector I, which means I can just straight up remove those. Okay. And all right, so we basically move from the frog position to one tile in a position that we're looking at, which is where the frog travels. And they basically need to check if flies have the position of vector to I. Perfect. But vector to I is a tuple. Therefore, we can do a check like really easy, I think. Although probably will be the same with the object. Because I think everything tries to be compared by value. Where they go? Here. So if fly positions, contains the current check position. So if it does, that means the frog satiety is 1. We refill it. And what? Done checking. Because this will be a loop. We start from here and from here. So this could be like while current length is less or equal. So while not no hit or. So let's do var no hit, which is false. I mean, which is true, right? Okay. No hit is true. Let's do is hit, not is hit. Okay. Looks more conventional. So we're gonna do is hit is true. Okay. So we found apply, and we're good with that. Okay. And we just need to remove that thing. So it'll be fly positions dot remove, possibly. We'll probably need to import sequence utilities or something. We'll see in a second. So if it contains it, if it doesn't, we need to basically increase the length. So let's start with length of 0. And in the beginning, we basically do need to indent it one more level. Current length plus, so just increase current length. Do this, check all that. And if not, nothing happened. So at the end, if not is hit, then we're gonna basically take the cost. But if it was hit, that means we ate it and therefore we're good. Sure. Let's see if it works, if those flies will disappear. I mean, first of all, it won't compile. Because of reasons. Right. Undeclared routine, remove. There we go. So let's do sequence utils. And run again. No remove. Delete. Top mismatch. Okay. Yeah, that will be it probably. So we need to. I wonder if I could make it as a set, but no, let's not complicate it. How do I delete a specific element from a sequence? I have a tuple. Let's just give it a code. Okay. So I have this as that. Ooh, you can't make whatever. Hate it. The indentation problems because the language is. I have love-hate relationship with the whole indentation requirements, like Python does. I often don't like it because you can't just write code, mishmash, and hit reformat to make sense of it. You actually need to do things. If you want to refactor, you suddenly need to start moving code around, hitting bunch of tab and whatnot. It actually adds more work than it seems to save in the first place. Okay, so I have this. I need to remove. Let's just add one more, like 15 or something. Element X from remove element from what is it? Fly positions. Okay. Let's make it a comment, and let's make it that var element is. Let's just plop this one so that's in the center. There we go. Wow, colors went all over. That took way longer to ask this question. So yeah, we have string utilities. Okay. That's fine. Seriously? Oh, geez. Keep it if, filter it. Yeah, I like the. Keep it if. I haven't heard about that one. Using delete with find. Too bad. Or use a hash set. Sure. Let's just do it this with this whole keep it if is not that. Well, I haven't heard about keep it. I mean, we could simplify it, right? Because we could just make a loop that goes over those. We already hold the index, and if we found it, we just remove the index, right? This way, we're gonna save ourselves iteration. So before fly position, comma index, And that's how it was. The other way around. Index, comma, fly position. We're gonna do if current check position is exactly as fly position, okay, we're gonna do all the fun things like this, that, and fly positions, delete index, and break. Okay, that should be it. Sure. CPN says 10 minutes ago. I gotta go now. See you later. See you. All right, so maybe this will work. Please work. Please work. Oh, it works. Play. So we've got the flies, right? I press Z. Nothing happens. Oh, it's thinking and it's thinking and it's frozen. Oh no. Oops. Let's crash it. What the heck just happened? While not is hit, we do this. We current length. We increase it. Okay. While it's less or equal max tongue length. So we keep increasing it. We change the position. We check those. So eventually we should break this loop. No problem. Why isn't it breaking it? I mean, if that was the case, this would be really silly. I see. Because, I mean, not really, because this changes too. That's one little problem, right? Frog position. We'll assign it here. And then we're doing all the fancy stuff. It's weird that it just froze. What now? What is the problem now? Oh, because we're setting it to itself while we didn't set it before. Ah, okay. And we're setting frog position. Okay, so let's just do our current position is the frog position. Okay. And we modify it by setting it to itself plus the offset. So that's first fix. But still, that doesn't explain why when I press Z. Oh, whoa. What? They both disappeared? It's as if this never was checking anything. Oh, because I need and. That's why. Silly me. Z, bam, bam, bam. But for some reason, it's only one long. Ah, okay. We just never update the actual tongue length. So if we're gonna do this, we're gonna set the tongue length to the current length. Come on. While here, we're also gonna do tongue. Current length. I mean, we don't even need to do that. We just do tongue length. Okay, we just set it here. And we keep increasing it here instead of doing other stuff. Yeah, there we go. And therefore, we don't even need to modify anymore. Okay. That should work a little bit better. Boop. Whoa. That is a little bit longer than I expected. 4 tiles. So, but look at that. It works, refills. Okay, cool. So why is it so long? Oh, well, it's smaller than length, right? Because this already covers the +1 length. Okay. So now we can eat this guy. We can go somewhere here. And we should be able to eat it from this side. There we go. Let's just die and... Ooh, that doesn't respawn our flies. But I don't worry about it now because... it's not a problem. I don't eat it from here. I eat it from here. I can eat it from here. Perfect. And it stops where the fly is. Where the fly is. Awesome. So now let's just check, because I checked bottom left. Let's do down. And I can get over the fly. Okay, bam. When I'm over the... oh, I died. When I'm over the fly and I won't catch it because it's over me. Huh, that's an interesting little mechanic. Sure. Okay, code works. We can check the box off with the add satiety refill. So now let's keep working on those flies. So add fly movement. Then will be add a fly spawning. And sure. Let's do something like that. I would like there to be a fly basically every time we eat a fly and the other one comes onto the level or something. Maybe for the beginning. Or we just spawn them from time to time until we reach maximum number of them on screen. I don't know. But now let's think about the movement, because the nice thing about the thing that could be nice about the game is that, let's take the fly here on top, is that, you know, the time moves when the player moves. And therefore, we can make things move in a pattern because we give the player enough time to think about what's going to happen. So with the fly, we could make it that it just goes down, goes left, goes down, goes right, goes down, goes left, something like that. It could just fly like this. Although it would be probably more realistic if it had a little bit more interesting pattern. But we're gonna get there eventually. So let's do something, something like that, something really simple. But that means that we need to keep track for each fly, what is their state? So that means that instead of just having them as those positions, we should actually have some kind of idea about a fly. So let's start slowly restructuring things, okay? So let's make a new folder. We're gonna make it entities, okay? And here we're gonna make a new file, fly.nym. Not fly.io, not fly.io, fly.nym. So here we can make a type. fly data, okay? I'll make it like that, not just fly. Let's make it fly data. We have the position. That's what we need. And then let's add movement. Let's make it step, okay? And that will be the integer of which step in progress it is. And therefore, we can make something like constant fly movement pattern. And we just make it a sequence of directions. Like up, down, left, right, or whatever. So let's think of a pattern. Let me see if this looks decent on stream. Let's just start a game. So let's take the fly on top. I will try to take a screenshot. Okay, it darkened. I don't know if you can see the screen. I really don't know. Okay, let's just make it a bit differently, because I don't know if I was sharing the screen or not. Paint, shield your eyes. It's gonna be bright. You can fill it with black. If that's gonna work, there we go. So now we're gonna grab white color. Sure. So let's say that we have the fly. Bam, bam, bam. Look at that. We already have better graphics to replace our current graphics with. So let's say that I would like the fly to go something like here, here, and maybe here, and then here, and then we're gonna go down and down, and the pattern will repeat. Okay, we'll have flies that move to the left and flies that move to the right. Sure, and that will basically make it go here, here, here. Okay, it will go mostly down. So be left, down, left, up, right, down, down. Okay, and they will come in from the sides. Let's just make it side by side so I can see. So if I move pattern left, so let's do is left boolean, and this will basically mean if it's left or right. So we'll do left. Can we just do here left, down, left, up, right, down, down. Okay, this will be the pattern. And then we do right, which will be the reverse. So it'll be right, down, right, up, left, down, down. Perfect. Okay, so these will be the two patterns that the fly can take. The whole idea is that it's obvious to figure out quickly which direction the fly is coming, because if it shows up on the left side of the screen, you know it will be coming towards the right. When it shows on the right, it will be going towards the left. But then the pattern is like, you know, not instantly obvious at which state of the fly goes. Therefore, maybe it'll be more interesting to, you know, more challenging to grab that food. Don't know. We'll see how that works. So we've got a step, if it's left or right, and now let's do proc. Not new fly. let's not worry about it yet. Or maybe we will worry about it. New fly, sure. We give it a position. Position, sure. Uh-huh. And then we're gonna do the position Y. How high up we want it. So let's do it in 32. And then we're gonna create position will be, this is where we need the random. And we randomized it, so how do we get the random? For that, I will look into the docs. Randomize. And that should show up here. This is randomized, right? So all the way on the top, we see an examples. Rand and just numbers from 2. Okay. From 0 to 1. So the direction is rand 0 to 1. So then we can basically do position will be then will be position X is if direction, let's just do let, I mean all of this should be let is left, basically if direction is 0, and then if is left, then we're gonna make position X to be 0, otherwise it will be map size X minus 1. So the position of left right will calculate itself automatically. In this case, to have this whole map size, that means we need to make sure that we actually import this thing later than this. Ha. So we have our constants. So sure. Gosh, it would be nice to extract constants to somewhere else. Let's do that right now. Include constants. Okay. So new file, constants.nym. We plop them here. Map size. So we need the vector to I. More vectors. This is just that. Okay. So that means this can be happily here. I would like the render to already know about the constants. For now, utilities no. Okay. All right. So we have the renderer and then entities fly. And this way we know for sure that this can use the map size. So that means the position X will be here. Position Y will be whatever we pass to it. Step always start at 0. And is left will be is left. There we go. So that kind of makes sense. Okay. So this will be how we create a new fly. But what I want to do is proc move. So we call it on flight data. Do I want to modify it in place? I'd say so. Bar flight data, because this way I can still keep it where it's supposed to be and not worry about it too much. Whatever. So we just move it. Okay. So the step is +1. So wait, step 0, we'll move it to the left. Blah, 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 blah. Okay, so let's do it that way. Fly dot position. We take the direction to offset. Look at that. We're already reusing stuff. And we're adding our eye things. Awesome. So we add the position and the direction. No. What the heck? Movement pattern. So we'll do... These are sequences, so I should be able to pass them by reference. So let's do let movement pattern. If it's left or if it's right, we just select the pattern. And then it will be the movement pattern step of it to the offset. Then we increase the step. If step is larger than the pattern's length or equal, we reset it to 0. And that is it. Okay, cool. Can we just do fly.step +1, and we just mod it over the length, and that will be kind of less to do, I presume. There we go. No need for the whole if statements. Math is faster. Okay, we still got 2 hours. So, all right. So the fly keeps moving. For now, I'm ignoring any possibilities that the fly will hit something, whatever. For now, it's just, you know, flies so can go over whatever future obstacles will show up. So let's consider it that way. Okay. So now what? We can move it. We modify it and nothing else changes. Okay, cool. Let's add this. Yeah, this is good. So now let's say that we already we can predefine two flies in here. So let's say that these are not that will be flight data. Okay. So we'll have new fly. Oh, Taras. How are you doing? Yep, I can see it both places now. Yeah, we're making a game in Nim about a frog that needs to catch flies to survive, that it needs to get back to a pond to be wet, and then there will be trash flying from the sky that the frog needs to kick off the map to not go into a pond and not take up all the space so that it can get to the pond. And for now, I mean, you'll see it in a moment what it looks like while after I modify this code. Okay, so new fly. This will be a fly on... Oh, because now we specify only the Z level. So it will be... What would it be? Let's do 1. I mean, or the Y level. Then... Yeah, that's all we specify. The rest is automatic. So we just do new fly. 1, and next fly will be on 2, and the next one will be on 3. Okay, we're gonna have 3 flies. We're gonna go nuts. Sure. But that means this randomize needs to be called ASAP. Let's just straight up call it up here. Okay? Because everything else is includes, so that's that. And then our code for checking if there's a hit, we had go over fly positions. So in fly, not positions. Where do we have fly positions? In that many places. Fly positions here, 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 and here. Okay, so let's make it flies, okay? We'll just call it flies. And we can handle a little bit better here. So fly data and flies. So if it's the same as fly data dot position, then do this stuff. And flies delete the index. Perfect. And what? Where else do we have flies? Nim code is so hard to scan through for some reason. Fly data, and we're just gonna do fly data dot position to screen coordinates, and that should be enough to make it run. Of course, after we get over the errors. Undeclared identifier, tile size. Oh no. So let's not define tile size in the render. Let's just do tile size is 64 over here as a constant. And you know, that should be good enough. So render tile size, go away. We also need to have tile size. There we go. And there we go. So we've got Windows stuff. Then we're gonna rendering stuff. Map. And bunch of moisture stuff and losses. Okay, let's try it again. Position X. Oh, let. There we go. Let's match tuple, this and that with. Was this what? Vector 2. So what's going on? We have a mismatch. Fly data position. It expects this to be in 32, right? And Y should be in 32. So what's the problem? Unless it was in 32. Yep, that was the problem. So we can, yeah, whatever. Then we've got this mess here. What's going on here? Type mismatch. Fly position plus equals this. Oh, because we don't have plus equals defined. So let's just do equals. I don't feel like defining plus equals right now. Or, sure, why not? Let's go to common. And we have those three pluses, so let's do something similar. Proc plus equals. And we just do this, and why do I call it an offset? This should be a V2. V2. Okay. Okay. Not V2. Other. There we go. So that means that if we do plus equals, do we need to specify it as a variable? I don't even know how to specify it properly. Because I think we're just doing this. Let's see if that works. Okay. If we have this here and we were doing this, we were adding both our, yeah, these are all just normal things. plus equals. Let's see if that works. Nope. Has to be used or discarded. Oh. Okay, this is weird. I am not playing with that right now. Don't have time for that. There we go. And let's remove this weird thing. Okay. This should be good enough. Let's see if that second line is problematic. Of course it is. So, of type boolean, and it has to be used. Oh, why do I have double equals there? Oh, let's see if it works. We've got our... It's a 2D game. Yeah, I misspoke. It's also be 2D game. Looks like a lot of dynamic features. Not that dynamic. Okay, so we've got three flies. They randomly showed up on left or right. And I should be able to still eat them, right? And they should still refill me. Okay, so this one disappeared. And I died from not having enough moisture. So let's actually decrease this whole moisture loss because it's just way too much. Now I'll be on par with hunger. Okay. So we can eat this guy. They got different arrangements, so that's good. Okay, good. That's awesome. That works, and I didn't get to that pond. Okay, this might end up being a difficult game. So I've got that part. The next thing is that we need to decide how often the flies need to actually start moving in a direction. So there'll be another thing. So, because one thing will be that every time I take a step, the fly moves, right? That could be actually interesting. Let's try that, because that might mean that they're moving fast. The other option will be that something moves every, let's say, 3 player moves or something. But with flies moving so fast, it might be actually a bit more challenging to properly time it to get to the fly. Okay. So we just need to start calling move on them. So some kind of update. So in here, how do we structure it so far? So far we have the user input, right? And then we had the movement, and if the movement happened, only then we're applying some things, okay? But we should have another variable saying if the player took an action, okay? Because one action is, lick with your tongue, the other action is to move or rotate or something. So let's add another variable for player action, and let's do it false. Okay. Player took action. Use to determine action that moves the time forward. Okay. So if that's the case, first thing we have if the Z key was pressed. If the Z key was pressed, we could actually make it so that when we release it, only then the time moves forward. Okay. So let's do player took action is true. So then, if the player moved, okay, at the end, additionally, player took action is true. And then we have the pond stuff. Then will be detect that the frog is dead. That's another thing. We can just make them clump like here. So then we need to process the movement of entities. Let's do it before this happens. And before this happens. So let's do if the player took action, increment the time. Like let's do, sure, increment the time. So let's actually have some kind of thingy var time. Let's do turn is 0. Okay, I'm gonna put it all the way at the top. Turn is 0, and we'll be counting them, and that should get us somewhere. So basically, where is it? All the way here. So if player took action, increase the turn, and then we're gonna start progressing all the things. So it'll be process entities. For each fly and fly data, we're gonna do fly dot move. Okay, just move, and it should keep track of its own thing. So it's gonna just move around, and that's it. So instead of calling it move, let's call it update. There you go. And because everything is turn-based, we don't have to provide, the delta time things and whatnot. We'll just call it update. There we go. And it should take care of itself at this point. I mean, we don't have any other things to move around. And I guess if player took action, that's when we should actually, when the time moved, only then we would take some extra action. But this is already saying that we took action, so we can take care of moisture here because, bunch of stuff. Well, let's just leave it the way it is. I'm just thinking if there's anything else. If the frog is in the pond, this is just absolute. Sure. And sure. Okay. So drawing stays the same. Let's just see if something is actually going to happen. First of all, bunch of errors. Of course, flight data. Duh. Of type flight data and has to be used or discarded. Really? I'm returning something here? Flight data. Oh, this is calling something else than what I want. Update code. Oh, I see. Move, whatever. Let's rename it back to move. There you go. But something tells me, because this is land instead of var, I don't know if it's gonna work. Fly data is immutable, not var. I see. So I guess we should go over a little bit different things. Right now, the flight data is an object, so let's actually do it a little bit differently. Let's make it that the flight data, for the purposes here, is just, instead of being object, it'll be a ref object, okay? We really don't worry about performance here at all. Therefore, we don't need it to be var. Hello, beef. I didn't expect you here. That's awesome. And you already have helpful little tips like flies.mitems. Oh, that's true. You'll be shocked by how little I learned by reading all those documentation things. One thing is to read through documentation, the other thing is to actually practice. So you're saying M items, and that will be modifiable items. That's true. That is smart. Sure, let's try it then. I'll probably eventually just put it back into refs, because why not? I mean, it's very little data, so I guess it doesn't matter. Var M items. Let's try that. And flies.m items. Okay. And we have var fly data. Look at that. Thanks, beef. And it turned on. Let's see if the time will move forward. I move forward, the fly moves in the wrong direction. But they're following the pattern. So at least that's that. I see. So when I made them show up, the position is left, means it's gonna go to the left. So I need to swap those. It's the direction, not the placement. And we start again. And I move. Now, how on earth did I catch the flies? I do here, and I can press Z and I hit 1. Okay, and that already moved time forward. So now I guess go here or not. Okay, I can eat this one. This definitely needs a mechanic of wait. And it's over me, and I can't. There we go. Okay, this is gonna be challenging. I like it. Sure. Okay, so we have a first example of something that actually moves and we can somewhat interact with. So now another thing would be to basically add some kind of constant or something. Oh, let's not make it constant. Let's make it variable, because that's more fun. Let's do var max fly count, and let's make it that at any moment at the screen there are only 2 flies. We don't want any more. And let's do var fly spawn interval, and this will be something like, I don't know, 10 turns or something. Sure. And then fly spawn max y. Okay, so that will be map size y, maybe divided by 2, so that they don't spawn too far. I mean, too far down or something. And that means we can basically, doesn't mean that we need to have a bunch of counters that basically count how many steps have passed since last interval. I think so. So let's do var fly spawn timer. We'll do 0, and we can basically go over those timers. So we went through movement, we processed the entities for the flies, and additionally, maybe before we even move them, no, first let's move them so they can get off the screen or whatever, and then we're gonna spawn in new flies that won't move initially. They will just show up where they spawned, because normally they would just instantly go onto the different part of a screen. So let's do fly spawn timer, increase by 1, and then let's do equals +1, and we're just gonna mod it, okay? Mod interval And this way we can just check if the timer is 0 and fly's length is less than fly count. Perfect. Then we're gonna just spawn a new fly. And then we're gonna need to have the y, which will be the random. So be rand from 0 to spawn max y. Yeah, and add it to the sequence. And let's try it, because this means that we should have them, you know, spawning on an interval with, wait, what? Fly spawn timer. There we go. More errors. Really, is that annoying? Okay. So this, wait. These are always so difficult to read. Basically from random here to here. System integer to system float. How is that? Oh, because we divided by 2 and we want to basically round it down to int 32. This will be int 32, or what was the thing? Int I32. That should be the more proper way for some of those to be defined. Okay, there we go. Please work, please work. Nope. Wait, where did I have it? So it's from 0 to oh, this one is int. Of course. And probably needs to be an int. Both of them, right? Let's see if that's gonna work. Please work. Okay, we've got the same item. It should work. Okay, we start here. We have 3 flies, which is already over a limit. And we can just go here. And bam, we ate 1. Two. And now, oh, we got another fly somewhere there. Eat this one. And we go to the pond. While the fly is already, gosh, they really go like flies. Okay, this should be sufficient to get somebody by. Okay. So the other thing is that because they will just fly off screen, they need to actually disappear once they get off screen. So that's another thing. We need to keep deleting them then. Okay, so we already have somewhere kind of here location checking if it's off the screen or not. But I guess we need to add another little utility function to just check, is it off screen or not? So we have common, we have utils and constants. Maybe we'll move constants above utilities, and therefore in utilities we can just add those little checks. Like proc is in bounds. Okay, and we're gonna basically make it. Do we want this as a rectangle or something, or do we want it as something else? Let's make a few variants of the same thing. So let's make it a rectangle, rect, and a position of, let's say, vector 2, and I believe I can do, or vector 2i. Maybe. I never use those, so we'll see how that works. So if it's in bounds, How do we do that now? So let's do if. Let's actually make it use something simpler. Proc is in bounds, and we're just gonna make it start X, start Y, stop X, and stop Y. So let's just do minimum X, maximum X. That will just make a little bit more sense. Minimum Y and maximum Y. Okay, these will be all in 32, and position will be either this or that. So let's do. It just does this. Can we compare none in 32 with in 32? Or just straight up, everywhere I have position, I just force it to be in 32. Let's see if it works without it. If it has problems, we're gonna fix it. For now, it's upset about something not closing. I guess I thought I could do or maybe I'm just completely going bonkers. Vector to I. Sure, let's do that. And that should work no problem because everything is integers. So if we have rectangle and we give it vector 2, then we can just call this, okay? And this will be 2 I2, I think. That's what I defined. Common to 2I, okay. Okay, that should work. And then I'm just gonna make another variant that's just with this and whatnot, and you don't have to call it. And let's just have it like that. Now I want to basically start using it, and that will be inside of somewhere here. So on top of this, because we have constants, which tell us the map size. So I could basically make proc is in map bounds. And we just do this. Okay, the position. And we're just gonna make it from 0x to map size x minus 1 and this, and that's it, is in map bounds. Sure. Now look at that, we can start checking for the flies if they are out of bounds or something. So where was it? We move them, and after we move each fly, if so we have m items. Can I do index comma m items? But what would happen if I'm gonna start removing from the list after the thing? I better not do that. CPN says, hi, what's the progress so far? So far we have flies actually moving around. Let's see if this still works, if I'll just compile it this way now. Nope. What is the problem? Top mismatch. In here. So this isn't happy. Oh, because that. All this needs to happen everywhere. Everywhere. And we'll have the same thing here. Okay. Sure. Easy enough to fix. All right. The game started. And we have the flies. And you actually need to try to catch them. And it's less easy as one would think. And the other thing is that they just come on, where are you going, fly? Keep respawning until we have max of 2 at some specified interval. So we can keep eating until we die of moisture or something. It's not that difficult, when you have some time, but when some other things will start happening in the game, it's gonna get harder. So I'm actually excited. All right. So what now? Isn't map balanced all that works? So the whole thing is that now after we basically move all the flies, I'm basically for each fly, I need to check if it's out of bounds, and if it is, it needs to get out of the list, disappear. Just yeah, it actually looks less bad than I expected. Let's actually commit the code for now, okay? Because I forgot that GitHub exists and we need to put it here. So let's do a bunch of this. And Beef, if you're still here, I'm really sorry about the code. I know your eyes are probably bleeding. And probably ears too from things that I'm saying. Alrighty, so let's do working stats, flies, fly, and spawn. Okay. Bam. Still have an hour and a half. So we'll for sure have flies done and maybe start moving some trash. Or at least letting it fall or something. So with the flies, so maybe after we have all the flies done here, before we add new ones, we'll just go over the whole iterator with basically checks. Doesn't need to get destroyed or something. As in a filter or something, right? So let's do flies and what was the name of those things? Because they were a little bit not as filter. Is like IT filter IT. There we go. And we basically say that to filter here will be true, will be to keep it, false will be to not keep it. So let's do is in map bounds. It'll be the iterator because that's flight data dot position. Is it gonna be enough to just get rid of them? Let's see if it even compiles. First of all, nope. It doesn't like it. Let's see why. Expression of type blah blah has to be used or discarded. Oh, duh, of course. Flies is this. Because this just creates a new sequence. Okay, it might compile. So now I'm just gonna spin here forever, or probably I need to eat some flies if I'll manage to not die. And it's gonna disappear. Yes, they disappeared completely. So let's get ready to eat one. Okay. Come on. Oh, they will all probably go through somewhere here. There aren't enough flies for me to not eat them. And I died from hunger. Uh, sure. So one thing that I just noticed, when we die, we need to basically reset flies to nothing again. So let's do that. Flies is an empty sequence, okay? And let's actually start with empty sequence. Because this way they will just start coming in naturally as you start the game instead of having them around. And make the flies hang around on the top part of screen. I mean, that will be one option. For now, the flies, the way they go, they follow pattern. Because the idea is that everything on the screen will follow a specific pattern of movement. And, you know, things move only when you move. So you can kind of predict the path. And the path right now looks like this. Left, down, left, up, right, down, down. And that means they kind of looks like random, but it actually isn't. And they do it either from left or from the right. So yeah, that's the current idea for the movement. And for now, I'm satisfied. I'm just like, let it have it. I just need them to spawn from nothing. And therefore, if we clear them, they will all disappear when the player dies, and therefore everything should be fine, right? No leftovers after death on screen. So we go up, and we got our first fly. We eat it, and we got this one here. Gosh, even though they have no pattern, I just can't predict it. Okay, I start again and starts from scratch. Awesome. All right, this works. Fly is this spawn of the map and the spawn after the death. So for now, I'll consider flies done. There we go. Flies, this spawn off map. And after player death. Okay. We're good. So let's look at our roadmap because I think we just went over everything. So now the last thing to do is to have the trash. So we have an hour and a half to finish the trash. So we need to basically make trash make two types of trash. Okay. Make them progress down. And then we'll be make them spawn at some rate. And make them take up room permanently. The other thing will be make them stop player. Make players stop them, at least some of them. And then it will be basically add lick pull and add kick. So this is where the fun begins, kind of. So let's start with some basic trash. Okay, let's make some trash. So we'll add a new file for entity. It'll be trash can. Trash underscore can, okay? Or just trash, sure. Because they will all behave roughly the same. So let's have the symbol data and actual symbol pattern. So the whole idea is that we have trash data. Let's make it into something where we have position of the trash on the map. Then we're gonna have step. Sure. Step, and then we're gonna have no weird is left. Let's say if I'm gonna put kind, it's gonna think that I'm doing some weird stuff. Let's make it variant, and I'll be trash variant. So we just need to make trash variant, which will be can, and maybe the other one will be bag. Okay, or no, something that could actually fill up the pond. A trash can. I mean, trash can is large for a frog, so that's good. And then we have what are kinds of ponds are? It looks like it can be on the pond forever. One could be, but then you're gonna starve to death. So you need to go out and basically go back and forth between pond and flies. Whatever. Box. So these are the two kinds of trash. And therefore, let me think. And therefore, we're gonna do an additional thing that each trash, because we have either an option. Yeah, let's do that. Trash movement patterns. That will be a hash set, right? Or doesn't need to be hash set. Could be an array. Yeah, let's make it an array. Array via trash variant. Okay. And what it's gonna hold is a sequence of direction. Okay. And that means it's, and we create an array where the can will be something and the box will be something. Some various different directions depending on what. And then we can basically take it. Okay, if it's a trash variant can, this is its movement pattern. But the thing is that I kind of would like to expand this whole idea of the thing, that it's not just the direction, because I would like the thing to also pause for something for a moment. So we had the common. In common, we have this thing that we can then convert to the offset. So what I'm gonna do, I'm gonna also define movement direction. None. Okay. I'm just gonna do it that way. It would be fun to add it actually in a diagonal. Sure, let's do that. That's gonna add some variety. So let's do north, northeast, east is that, and let's start with none. Okay. Sure. And instead of movement direction, we'll call it entity direction or something. Pattern direction. Sure. And we're gonna make similar proc to offset. And direction will be the pattern direction. So none will be nothing. North, northeast. There we go. This should be good enough. Yep. 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 Looks good. Okay. Wow, that didn't took much. So let's make it like this. Instead it'll be pattern direction. So for simple directions, moving directions, let me think. How does one move around here? Oh wow, there are no shortcuts here. So for a can, I wanted to kind of roll, then do here, pause, and then do another roll, go down. Sure, so let's go down. This, pause, bam, 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 pause. And we just go here. And that repeats. Sure, I can do that. It'll be just rolling in a squiggly pattern. Down. Oh, I mean, he'll be south. Southwest. None. Southeast. Southeast. Then it's gonna be south. None. And southwest. Oof, that was painful to write. And for the box will be simple. Down, pause, pause, down, pause, pause, down, pause, pause. So let's do none, down, none. Okay, something really simple. Sure. So what can we do? Because we have this, we have fly here. I wonder if we can just move the rendering of the fly to the fly itself and clean this thing up. Sure. New fly, move, and then we have draw. Okay, that's good. So similarly here, with the trash, we're gonna make it draw. Just position. Draw trash, and this will be, It all depends on what kind of trash, right? Draw trash can. Start with that, and we're gonna do circle x minus 15, y 0, and size 10, sure. For now. Let's do 14, and that will be red. Okay, will be Coca-Cola. Then we're gonna draw another circle, also red, but it'll be here, and then we're gonna draw rectangle. Position X. Let's do it like 16 or something. Wait, this is 14, so we'll be minus 15 to position Y, that corner, minus 7. No, minus 14. Oh, that'll be large can. And then we have Oh, because this is size, so it'll be 30, and here will be for 28. And also red. Maybe that will be enough to make that trash can. So let's do need to tell which trash, right? So let's do trash data. Trash data. And this, okay? And this way we'll be able to call it on the thing itself. So then we're gonna do that case trash data variant of can, do this, and box, draw trash box. The box will be a little bit easier. Trash box, position and rectangle minus, sure, everything will be 15, 15, 30, and 30, and that will be, I don't know, yellow. Whatever. Just a rectangle. So this should take care of drawing those boxes and stuff. So next thing that we have here as compared to here is the way to create a new one. So let's do proc new trash. Do we just, no, let's do trash can. We'll specify them, like, you know, specifically what this thing is. And here we have the pattern to spawn. So pattern to spawn them will be position X, actually, because where we want to spawn them on position X. And that will be in 32. And that's it. Okay. So what we're going to do here is new trash data. Y will be absolutely 0. And step is 0. Although here step could be actually random from 0 to a high of trash movement pattern. Actually, not high. It's just length. And the variant will be can. And that's it. We've got a new trash can. And the same thing with the box. Come on. Copy, paste. Box. Position is the same. Box and box. There we go. So we have a way to spawn them. The last thing is to move them. So proc move trash, or just move, and it will be trash data. So the movement pattern is just depending on the variant, and then all we do is update the position to the pattern and step, at least for now, because in the future we'll need to suddenly start taking into account the collisions between things. But for now, this is good enough. So we have all the things here. So let's go and implement those. Let's go to drawing first. Processing draw. So here we draw all the flies. Next we can do basically for trash data and trash. I don't want to do that. No. Trash can data and trash cans. Draw trash. Each one of them. Okay. Sure. Yeah. Interesting, because now we give it a trash can data because it needs to decide which trash can to draw on its own. But maybe we won't do that. Let's just do it draw trash can. Okay, this will simplify things on... Actually, I thought that this would simplify things, but not really. There we go. Okay. Draw trash can data. We make sure that we convert it properly ourselves. For trash box data, we do the same thing. So, sure. Now let's actually get the data in place. So we've got the flies count. Then we do our trash cans. Max trash can count. No. Let's do it. Trash can max spawn interval. And we're just gonna say that at a maximum every 20 moves. Trash can minimum spawn interval will be maybe every 10 frames. Or 10, whatever, something. So the next will be the timer. And we just set it to something until it goes down to 0. Next will be the list of trash cans. And that's it. So we can do the same thing with boxes. Exactly the same thing with boxes. But we're gonna make it they will show up a little bit more often. 15 and maybe 8 or something. So what now? So basically, we need to start handling them. Not movement, process entities. We do the fly data and we move them around. And we do the flies. Okay? Then we can basically fly entities. Then it will be process trash can entities. So basically for trash can data, we call move on them. Okay. And then let's say that the ones that are off screen just disappear. Okay. So we're just gonna do to do handle kick trash cans. Okay. This way they go off the screen. Or maybe not, because whatever we kick off the screen we'll just remove immediately, right? So we don't worry about that. And the things that go down here, we don't worry about either. Although things that go off screen when rolling, that would be good. So yeah, let's keep it here. And let's make it things might roll sideways. Okay. Just a little comment. And the same thing we're just gonna do for boxes. Okay. Sure, boxes won't do that, but we'll keep it there just in case something's moved and we didn't clean it up. So an additional thing after that will be to make them stop at the pond or when there's no more room down or something, but we'll get there. For now, we want them to move down. And the thing is that how does the move work for them? Okay, so for them, it goes like this. It just goes over all the steps. Okay, so that's good. So now we need to get to the point where we're spawning them. And when are we doing that? We have timer here. Ah, okay. I see. So after trash can data, we'll have timer. So let's do let's actually decrease that timer. Trash can spawn timer. Is that a thing? Yeah, trash can spawn timer. Is this -1? Okay. If it's 0 and we don't have max number of trash cans or everything, they'll just keep spawning. So if it's 0, then we're gonna add new trash can. New can will be new trash can, I believe. And then the X will be basically random from 1, because it goes a little bit to the left. We don't want it to be already at the edge. And map size X -1. What dimension is map size? Okay, it should be vector 32, so we should be fine. Okay, cool. Okay. And then we'll basically do trash cans, add the new can. And then after the timer went down to 0, we just basically need to specify that the trash can spawn timer is random. And we basically go from the minimum to the maximum interval. And that's it. I don't think we need that. Hopefully. And the same thing will go here. Trash box spawn timer. If it's 0, new box, new trash box, blah, blah, blah. Yeah, that should be it. Let's see if it compiles. Of course it won't. Trash data. It doesn't recognize trash data. Really? Why is that? Oh. There we go. Now it's gonna work, and all this failing. Lovely. Invalid indentation, because this needs to be a colon. Alrighty, Taras wrote probably long time ago that it's time to go. And go to sleep. I hope you'll sleep well, Taras. I'm so into the code that I'm forgetting to look at the chat. I guess that's what time pressure does. Now, invalid indentation number 2. How so? Because we have double thingy here. Okay. And the same thing here. And hopefully that's enough. CPN is still here. Hello. I'm in the terrace. I was saying goodbye. Righty. What do we have? South. It's funny how Nim just goes random spots to find errors. Oh, south. Oh, it might compile. Let's see all the trash in the world. Oh, we've got a red can and a box. And right now we can't interact with it. But wow, that is a lot to handle. Holy macaroni. That's a little bit too much. Yeah, let's decrease the number of the unidentified flying objects. trash can spawn interval is maybe from 30 to 20 because it will take a lot of turns to get to the trash can, aim at it, kick it off, and all that stuff. Okay, and here we're already gonna do random from here to here. Okay. And that needs to be in 32. Make the trash fall in a straight line. Yeah, that's what the box does. The box goes straight line. The can is the thing that goes fast and swirly. And, you know, the idea is to add like a bunch of those. So let me just make sure that they are not spawning as much as they are now. Because it's a little bit ridiculous. Let's see if this makes any difference. Not install, what the heck? Come on, run. So we run, we go up, and we got 2 of them already. How so? They were supposed to be spawning when it's not that. Okay, and there's the fly after so many turns. I can't catch it. Bam. Okay, I caught the first fly. Well, the boxes are still falling. So they can't go fast, and this is where the thing would freeze because it can't go down anymore. Yeah. And the idea is that next will be, whoa, what? Oh, they're not resetting either. Oh dear. Yeah, let's add them to resets. Frog dead. Flies nothing, trash cans nothing, trash boxes nothing. Okay, they will reset. But why are they spawning in that weird rate? Because trash box spawn timer, if it's 0. Oh, because this is tied to a fly. There we go. And we can just decrease it, right? Instead of playing those weird things. Decrease this. Okay. Now it should work as intended. Where they are showing up after a while. Because initially there's nothing. You can just get yourself in position. There's first fly to catch. Bam. And at this point, you're ready to handle the boxes. And, you know, you could lick it. And you could kick it and other stuff. Okay. We're good. We have trash flying. So let's check some boxes off. 2 types of trash, yes. Progress down, yes. Spawn at summer 8, yes. Take them, take up room permanently. So that's another thing. So we would need to make it in a way that trash should have an extra value. Is stuck. And if it's stuck, it won't move anymore. The move, when we call move on it, it will just stop. So basically, we calculate a new position for it, right? So if the trash data position.y is equal the map size y minus 1, which is basically, you know, has it reached the pond? Make it stuck. Okay, so we do if yes, stuck is true. Another thing is that here we need to basically do something like let new position is this. And we need to do check if position is available. Okay. So check if the position is available. Okay. Something of that sort. So we can make that let is available. For now, we're just gonna say it's true. It's always available for now. So if it's available, we're gonna have the same thing that was happening so far happen, okay? We take the step, we take the position, we check if it's stuck and whatnot, okay? That's for it's available. But if the position is not available, else if it's not available and the else so it's available, we should also get something like, you know, the object that's on that tile. Let obstacle is obstacle stuck. So this is basically if not available, check if the object there is stuck. Okay. So else if the obstacle there is stuck, we make this one stuck as well. Otherwise, we just wait until next frame if we can keep moving. And that will be it. We'll just need this whole check for is position available there and how to get the obstacle from there, which we're gonna get to. It should be relatively easy. But for now, things on the bottom will just stick there and that's it. So let's see if that simple part works. And for now, you know, this is only for trash because flies, they fly around. So I'm just gonna, all I'm gonna do is look for the flies and play until the trash starts reaching bottom. Oh, what the hell just happened? And handle exception, index 3, not in 0 to 2. Really? Trash data, step. Oh, look at that, because we're not doing something with a step. Or do we? Segmentation fault? I don't think so. That would be very strange because I'm not doing anything, you know, unsafe. Let's see. So the thing is that it happened here. We define a new position and just the trash position plus movement pattern, take, and to offset. I mean, first off, this needs to happen, okay? And then we're gonna do this when it's available. And if trash position Y is map size this, and we say the stock is true. But that is it. And this never fires because is available is always available. Weird. I want to run it again because I don't understand where there could be a problem. Come on, flies, come to me. First one. Second one. I need to do here. Oh, I think maybe I was about to die from hunger. From, what do you call it? From lack of moisture. So they're not getting stuck on the bottom. Oh, obviously because I didn't add the check for it, it's stuck. If trash data is stuck, return. That's it. If it's stuck, just don't process it. As simple as that. I know it's not the most optimized, but with those numbers, it really doesn't matter. Come on. These flies are really annoying. Which is great. Okay. Ooh, I'm gonna die from moisture, but this block there got stuck there, so it should work. Okay. That works. All right. That's that thing when it crashed. I wonder if it's something to do where player died and it still tried to process something. Let me just double check. So we go here. Have all those timers that do whatever they do. But at the end, we're checking if player's dead. But where are we cleaning the whole thing? We have the update, handle the requests, whatever user input, everything here. So that's good. Mhm. Oh, I'm cleaning them up here in draw. But I'm just setting them to this, so I don't think this should be any problem. Yeah, we'll see if we're gonna get that problem again. I don't know. We'll see. So let's check another box off. Now or maybe not. Because they get stuck down there, but I also want them to start stacking and blocking the player overall. So what we need for that is basically a way to check, is there something in this spot on a map? And this little thing should be able to iterate over everything. And either is it blocking or is it non-blocking? So I'm going to, because this needs to use all those. So how do I implement that so that it can actually work in some, decent way? So all these can be variables, but just global. I don't care about all that, right? It doesn't need to be here within the game loop. And these are not constants, they are just variables that need to be available, whatever, globally. And they, in theory, could be just implemented within the fly itself. Yeah. Fly spawn interval, timer, all that stuff. Sure. Let's put everything fly related to fly. So fly data, all this stuff. Do we use anything like new fly or something? No. We just define the global variables here. And let's get rid of all this stuff. Bam. And therefore, all the fly stuff could happen here. But that still doesn't solve any problem with being able to check for stuff. One thing is to reorder, the other thing is to yeah, I think we're gonna do it in an interesting way. Let's just have it here for now. I'm just gonna move this stuff around. The same thing with all those. I can move probably both of those out of here. That will make scrolling through here a little bit better. So these are the patterns, and therefore we can just make all this a little bit cleaner. Okay, just random. Nothing crazy here. Good. We've got the variables, we've got the stuff. Make some spacing. Okay. So that means they are defined here and here. But what we could kind of do is make some kind of checker that all those could register themselves too. Like, hey, you can search through here with this function to check if something is an obstacle or not, or whatever, at a specific location. Yeah, let's do that. So we've got render. We don't care about render. We can have it before the render, I believe. So let's do something like include map helpers. Sure. Whatever. Collisions. We'll call it collisions because that will be the thing. It specializes in collisions. So let's do new file. Collisions.nim. And how we're going to do it. So the way I would like to do it is that we want to have a proc. So the thing is that we have few perspectives. We have a chat from Pingo XOR. Sup, can you make a game in 5 hours? Is it C or on Raylib? It's NIM with Raylib. The NIM programming language. Alrighty, so going back, we have is collision. I mean, we have several things that can kind of collide. And that's the common thing with game engines, where you have some kind of collision array, where you have various layers. So in our case, in our game, we have two things. We have player. Let me just make it a comment, okay? So we have a player, or let's call it a frog, okay? And we have trash. These are the two things that can collide. Flies just fly around, they don't collide with everything, with anything. So that's that. So we have the frog and we have the trash. And basically, frog collides with frog. We don't care about that. But frog collides with trash. Trash collides with frog, and trash collides with trash. Okay? And I mean, if there will be two frogs, they will collide with each other, I guess. And that's it. Flies, we don't care about. Let's do fly here. No collision, frog with fly. No collision, trash with fly. And we just want the visual. It's kind of visual thing for the fly to be there. Is it there or is it not? Oh, because one is for frog to interact, like we blocked, and the other is with frog or like tongue, right? Because when we do the tongue, we want to collide with trash because we want to pull it, and we want to collide with flies. Okay? So that's the difference here. So we could have two groups, as in solid objects and tongue. So let's do solids, and that'll be here. So solids, collide with solids, tongue collides with solids and flies. Okay. And that's all we need to worry about. So solids are things like frog and trash. Tongue is the tongue of the frog. Sure. There you go. Don't know what else to describe here. So let's just say proc is collision. We would need to do from solids to solids, or we just check for who's checking. So let's just do checker, right? So let's do something like position. So it'll be position on the map where we want to check. And then we're gonna do something, basically the layer and collision layer. Okay. So we're gonna do type collision layer will be solids or tongue. Okay. And then we're gonna do collision data will be basically very simple things. NGL, an AI code assistant, is a bit too much. NGL? I'm not sure if I understand that shortcut. Okay, so collision data. In my case, I want it to be is hit. Okay. And the other will be not gonna lie. It's a bit too much. Yeah, it's something you need to get used to and detect when to start ignoring it. So, and sometimes it can distract you. Yeah, that's for sure. So the one thing is that we want to detect if we hit something, but additionally we want to detect, what do we want to detect? We want to basically know if this thing is stuck or not. Is stuck. Okay. So let's do it that way. Is collision solid? And this way we don't need to give the layer. Because for the tongue, we will want something else probably. Not just, or do we? Because with tongue, we're just gonna lick something. And yeah, we want to know if it's a fly or not. So that's another thing. Like, you know, what kind of object type? Unless we do object type. No, let's just do solid. With solid, we don't care about object type. So if it's in bounds, so let's not check for is in bounds because, you know, there's no point. So for solids, we need to do check for trash and trash cans. Oh, that's another thing. We don't actually want to do it here because at this point, this collision thing, it doesn't know about, it isn't aware of trash cans or flies or whatever. Because when we look here, this is being defined way before we have the concept of a fly or trash. So what I would like to do here is basically have more like var, and this will be the Like we want to store basically references to procedures, to call, to check. So let's do solid checker. Solid collision checkers. Okay. Let's make it a sequence of solid collision checker. Okay. And make it solid collision checker. Can I make it an object or can I make it a proc that's basically takes a position and returns collision data? Let's do it solid collision data. Okay. Okay, so these will be solid collision checkers. And then we're gonna add the tongue collision checker, which will return tongue collision data. What a weird term, tongue collision data. Is hit, true or false? Is stuck, true or false? Because if we hit some kind of trash cans, will be something. It might be stuck. And then is food, boolean. And that's it. That should be enough for the collision data for the tongue. At least for now. We can always modify, right? So is collision solid? We give it the position and return the solid collision data. So what's next? Basically, for each checker in those checkers, right? And because we have a bunch of them, and we should have a bunch of for tongue. So for each checker, we basically want to collision data is call the checker with the position. If it's hit, return collision data. And that's it. We just stop here. And otherwise, if there's absolutely nothing, return basically it's hit false and it's stuck false. There we go. Just like that. The same thing will be for the collision tongue. We want to go for the tongue collision checkers. Check if collision data is there. If not, we basically make is hit, is stuck, not, everything's no. Okay, that's it. So that's CPN when this is where .ai just helps because it's copy paste. It's just a bunch of spots where you could make a mistake. And I know what I want at least. So for me, it's just tab. Okay, it looks good. I read it, makes sense. Don't need to think about it no more. I can move on. So that's that. But often you could spot where I'm trying to figure some kind of feature and I'm kind of it's not clicking and it adds on the confusion. So that's that. All right. So we have this. Now the only thing I want to add is basically proc a register solid collision checker. And we do this and the same thing with tongue collision checker. So now what I want to do is with flies. Let's take care of flies first. When we basically load the whole thing, we have our variables. I can do a nice thing. I can just add something, right? So okay, CPN says, I understand that, but if I used it, it would be hard for me to debug it later. Yes, it can be, because it's not exactly the code that you wrote. That's why when you read through it, you need to know that, if I'm reading something like that, I'm like, all right, if there's going to be a problem here, I know that I'm looking for it here. But if it will be something, more complex, then definitely you want to spend time reading it and reasoning about it. So at least you have some kind of idea. If you want to do that, then for sure. Yeah, it's a different kind of work. Okay, so after we do all this, we want to actually register the whole checker. So we can make proc check if fly collides with solid. Fly solid collision checker. Okay. So basically what we want to do is for fly data and flies, the fly position is the same. Then we're gonna say is hit and is stuck false. Oh no, with flies, we don't register that. Fly tongue collision. This way we won't even register anything. So let's do tongue collision checker. If it's the same position, then we're gonna return is hit, is stuck not, is food true. Okay. So now that we have it here, we can actually use it. We can change our current approach of checking for the flies, right? So looking, key pressed, calculate possible length, check, 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 and okay, current check position is hit and that. So we basically set the tongue length and current check position, and then basically we go over all the flies and do all this stuff. So what we're getting here is index. How could I get an index with it, I wonder? Maybe I'll just make it important to return index. I guess flies are unique because I need to remove them with something. With everything else, I just move it around. Or maybe I just provide a fly and say, hey, remove it. I think I'm gonna do that after a little short break. Need to run to the bathroom. So be back in a second. All right, I'm back. So I decided because we just have 20 minutes left, I'm gonna basically leave this the way it is. And I'm just gonna focus on the trash so that we can just get the trash data. So we can probably copy solution from here, right? We have the tongue collision checker. Let's do something similar. And we're gonna just plop it here. So this will be trash solid collision checker. Okay. And this will be the solid collision checker. So first thing first, we're gonna go over trash cans. So it will be basically for trash data and trash cans. The same position, we just say hit true and is stuck will be basically the trash data is stuck. Okay, we'll pass it into that. Otherwise, when we run out of trash cans to check for, we're gonna go over trash boxes and everything the same. And otherwise, we'll be returning just false if nothing works. Okay. So that's our collision checker. And after we have it defined, we can basically do a register solid collision checker. And there we go. Okay. Just have this thing. And then when we add more stuff, we can just register it too, but for now we're good. So that means that when we have the move, we can check if position is available, okay? So let's do let collision data is collision solid. And we just give it a position that we want to move the piece of trash to. And is available means basically will be is hit, right? So if not is hit, or like not collision is hit, we just move stuff. But if it's hit, we do if collision data is stuck. Okay. Makes it stuck too. Otherwise, it's just gonna, something's gonna wait its turn. So another thing that we need to add to those solid collision checkers, because we now have trash checking for collisions with other trash, okay? And that also means that it needs to check for collision with a frog. Frog standing will prevent the trash from going that direction. We won't go into, the trash is going to crush you. That's a little bit too much. So for that reason, we can probably grab everything frog related. Like start position. Or maybe start position not. Maybe not. Sure, why not? Frog position, direction, moisture, satiety. If it's dead, if the tongue is open, length. Yeah, all that is gonna go into frog. So we do include entities frog. Frog.nym. And we just define all that fancy stuff here. Okay, so we've got that here. Do we need to define something else? No weird types. Okay. So now the key pressed, we have the tongue related stuff here. We just leave it the way it is. If the player moved, player action. Yeah, let's just leave it the way it is. We can just probably call something like reset it. Yeah, sure, reset it. Reset frog. Okay. Frog, reset frog. And there we go. Just those few things. But what we want to do is do the what was the definition of it, because I liked it. There we go. Frog, solid collision checker. And we'll just do if position that we're checking for is the frog position. We say it's hit true, stuck, not. And that's it. And this way, we just also need to do a register solid collision checker for the frog. And suddenly, just by adding this, our frog will be detected by trash. So yeah. So let's just check for something. Let's see if it compiles, because we added a bunch of code, moved a bunch of code, and we just have type mismatches. Solid collision data is hit true, stuck false. Oh, duh. Of course. Oh, I'm making silly things here. Bum, 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 bum. So we've got this. We don't want collisions. We want to go to trash and say that this is it. And in fly, we need to just say that this is data. Although for now, I'll leave it there. And I can even do register tongue collision checker. There we go. Something tells me there will be something still related to that. Oh, no, it just started. Oh, okay. Move. Okay, we've got our fly. I can still eat it, so that's good. Oh, error. Okay. Exception. Index 3 is not in 0 to 2. Again, the same thing. Huh. And the trash nym move. So we get a trash data from here. We combine it with movement pattern of trash data step and convert this to some kind of offset. This is real simple code. How is that? What? Platform supported modules. Display, blah, blah. Blah, blah, blah. Everything's fine. Everything's fine. Selected. All this stuff is fine. So all that is fine, right? And then window closed successfully. What the heck? And that's in main 128. Trash box data move. And we don't have multiple threads here on it or anything. That's another weird thing. Huh. Didn't we have something like the not release, but debug or something? I don't remember if that was the thing. We just move here. Come on. We've got the first thing. We go up. Oh, the box itself got stuck forever. The other thing got stuck forever. That's interesting. Wow. What the heck? So trash data position is this and that. Collision data is collision solid for that specific position. That's fine. And if it's not hit, move there and did a bunch of stuff. Otherwise, mark yourself as stuck if it's stuck, or just wait. So that's good. So is collision solid? I don't like that name. Check solid collision. How about that? That sounds a little bit better. Bum, 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 bum. And we'll give it that new position, which is normal proper position. Okay, that's good. So what's happening here? We have the position here. We just go over the solid checker. We ask the checker, we pass the position. If it's hit, we return it, otherwise not. So that's like real simple. Therefore, if we go to the trash area, we have the checker here. So we receive the position to check for. We go over each trash can, okay? And if the trash can position is the same as we asked for here, then we're gonna return it as true. Then after we run out of those, we do exactly the same thing but with trash boxes. Otherwise, we return false. So what the hell? Is the frog checker messing things up? Check for position. And the position exactly as the frog position, which makes sense. Return true. Otherwise, return false, right? I mean, that's a default state. So I don't understand why they suddenly, randomly stop in the middle there. Okay. They just get themselves stuck. Huh. Am I checking for something opposite? But some of them were going down a few times, so that's very interesting. How it's kind of random. And the checker is doing stuff when the movement is happening. I wonder if that matters here. If that actually matters here. We're nearly out of time and I would like it to just work. So let's reduce something. Because when we go over here, okay, I'm just gonna get rid of some of the other stuff that I don't want on display here because there's no point. Oh wow, Jitspose rating with a party of 31. Whoa, hello, welcome everyone. You're coming from a game development stream, I presume? Jitspose says, never seen anybody do NIM programming before. Okay. Me neither. Other than myself. Yeah, I'm struggling with it a little bit, and I'm actually combining Raylib with NIM. They're binding sort out, so trying to do that somehow. Yeah. Right now we have we're making a game that I can actually run. There we go. I can play a game. We have a frog on the bottom that sits in a pond. So yeah, we have a simple game with a pawn. We have a frog. We can rotate it or move. Okay. So the whole idea is that the frog is there on the pawn is on the bottom. You need to protect it, and the frog has 2 bars on top. The blue one is for moisture, and the yellow one is for food. So you need to go back to pawn from time to time to refill the moisture. Okay, and then there's one fly that we need to go and catch, and there on top for now, temporary yellow box, which is basically trash that is following some pattern going down, and when it reaches the pond, it gets stuck in there, and it's supposed to block the player from getting there, and basically over time the whole thing will fill up, and you can't survive anymore. Oh, and with the fly, I can basically go and wait for them to show. Oof, yeah. For some reason, sometimes I'm getting weird errors that I am not sure about. But let me just show you that you can actually, I can press Z to extend my tongue and get a fly to refill the food. So, real basic. But basically, that's the whole idea. And right now, I was adding collisions for the boxes, and the red thing is supposed to be a can of soda going down. But for some reason, those collisions are just all wonky. I thought this was Nim. Yeah, it's Nim. I mean, Nim is surprisingly simple, but at the same time, it's not. So right now, the code just is hard to read. But at some point during processing of everything, we have a situation where the player took an action. We know that the player moved up or down or something. Yeah. I get the joke. So we have the situation where we know that the player took action, it's moved or rotated or I don't know, shoot their tongue or something. So we're processing over all the flies, we're processing over all the entities, this way flies can move, trash cans can move, trash boxes can move, and all this stuff, right? Real simple. And the way we do it is we iterate them. We get trash cans. This is basically a sequence of trash cans. And we call M items, which gives us a list of mutable items. And what happens is that move takes the mutable item and mutates it. The thing is that in there, we're making a check. We're iterating over more trash cans to check what are their positions and if everything is fine and whatnot. And something tells me this is causing some problems. I'm not 100% sure about it, but that's what it feels like. So my idea is now to basically redefine those trash cans from like objects to references so that I can have pointers to them and just iterate manually with indexes and whatever. So that I don't have those weird problems. I don't know. It's weird. Does Nim have its own game framework, or you just coming from scratch? This is Raylib. I'm just using Raylib. These are just bindings for Raylib, so it's pretty much the same. I added a few things like integer vectors or whatever, but all this code is really exactly five hours from now. Because I figured, this is gonna be the first game that I'm first time using Raylib other than going through some examples before. So that's why it's a little bit slow. So if I'm gonna go over this, I just want to check. So for flies, I can say that the fly data is not an object, it's a reference object. That means it's not gonna be by default on whatever. It's gonna be basically reference, which is, a safe pointer, let's call it. And that means that all the other code should stay the same, I believe. But what I can change is that when I want to move, I don't need to make it a variable anymore because I can just modify it. So movement pattern, flies left, blah, blah. All this should still work. I think. Let's see if it compiles. Or just, oh, now I'm calling the M items unnecessarily. But yeah, this flies still move. I can still go and try to catch them. So that part works. Okay. But what it means that when I'm iterating over them here, I could just iterate over them like this and not worry about it. Being modifiable or something, I really don't know if it's gonna change anything, to be honest. Really don't know, but I'm gonna do it anyway. We'll just need to update trash cans and items, and that should be it. Yeah, and what kind of game were you working on the previous stream? I'm curious. By the way, I'm not really familiar with Twitch. I'm not really the person that usually goes on Twitch and watches live streams. So, I don't know how the pros are doing it. I'm just randomly string what I'm doing. It's a retro FPS, but I was working on a steampunk motorcycle. Interesting. Going to have at least one vehicle in the game. So, alright, so it sounds like 3D, I presume. Because FPS, of course, first person shooter. How retro are we talking about? Gosh, retro shooter would be a fun thing to do. That's for sure. Okay, so I made it all into rough objects, but I don't think that's gonna change anything. Other than just not work anymore. Move will be just that. Okay. Does it still work? Yeah. Still works, still breaks. Index 3, not in 0 to 2. And that points at this. Trash data step. Oh, it's that problem. I see. Oh, of course. Of course. When I think I just figured it out. Trash data step is +1. Really mod with that and still doesn't work. Weird. Okay, so yeah, like Quake-ish, or at least how we remembered Quake looking, but a bit higher poly. Okay, that sounds cool. I saw that, this kind of... It seems like those retro FPSs are like a comeback genre, something popular with indie games. So that's awesome. I mostly watched them, never really played those new ones. That's cool. I never really finished a game. I worked on a few games before, but I worked in a game studio a long time ago. But that was Unity times and the beginnings of Unreal Engine 4. So I was stuck with Unity and the whole .NET 3.5. Oh, that was horrible. All right, so the problem is that in here, when we access the movement pattern, when we're accessing the movement pattern, what we're doing here is, why am I doing this? Oh yeah, I'm doing this correctly, yeah. We're accessing the movement pattern. What movement pattern is, we get trash movement patterns, which is here. Trash movement patterns. It's an array of, by trash variance, which is, just 2 elements. And each one is a sequence of just pattern directions, like south, south, west, whatever. So for a can, there's a number of, basically you can call them steps to go through. And what we're doing here is basically when we're moving forward, when at some point, if we did hit something or whatever, we need to advance that step. So we're advancing it by increasing by 1. And then I'm basically doing modulo by movement pattern length. So how many elements are in that sequence? So let's say there are 8 elements in the sequence. If I'm going to mod it by 8, it's going to be number from 0 to 7. So that should work. Why this doesn't work? And there's no other spot where we're increasing that step. Very strange. Do I need to just do... And the thing is, it just happens suddenly from time to time, randomly, rather than every time. -1 for now. Weird. Let's see if that solves the problem. If that doesn't solve the problem, it will be strange. It'll be strange. So the fly moves like it was, okay. Everything works, but they stop because they figure out there's a collision for some reason. And I died from not having food. Okay, so at least that problem might be solved. And the other thing is, why do they stop? So when trash moves, it checks if it's stuck. If it's stuck, it doesn't move. So when does it get stuck? There are 2 possible things, right? If it has reached the pond, if trash data position Y is exactly as the map size Y, which is it the bottom of the map? Then we're gonna set it true, that it's stuck. So that's it. Otherwise, we have basically, okay, trash, you're doing this. Select your movement pattern, calculate new position, which is the current position, plus the direction of the pattern to some vector, okay? So this is just moving one spot in one direction. So that's a new position. And when we're calling check solid collision, which is what might be the culprit of the problem. But it does that and does the check collision. So if there is no hit, we don't do anything. Otherwise, if the thing that we collided with is stuck, that means this piece of trash is stuck as well and freezes. So echo got stuck on other item that is stuck at position, new position. Okay, and that's the only thing I can really check, because here we checked if it's not hit. That means that it is hit here. Let's see if we're gonna get anything in the debug. Play again. Come on. Okay, and come on, where is some trash spawning? Okay, we're good for trash. We move. nothing. Move, nothing. So we didn't even get a message that it got stuck. Interesting. It just appears stuck. So maybe it's not stuck? How am I creating it? That's another question, because I have this here set to Boolean. And I have a little method to create a new trash can. I'm not setting it here, so it's stuck false. But that doesn't make sense that it would cause a problem. Yeah, you arrived when I'm stuck debugging. Expect something, but got this. Come on, where? Oh, we need comma. And I need to decrease those limits. Okay, so they're still stuck. This one moved, and stopped. What the heck? And it moved on diagonal and then on diagonal, which is, again, something that shouldn't happen. Something weird is going on here. And unfortunately, I can't just click here and hey, step by step. That would help so much. But that's what happens when you try to use a language that doesn't have that great tooling. Okay, so another thing that I could check is if this is not it. Let's just say that if this, check if the thing is even stuck in the first place. I am stuck. Okay. Let's just see if that will do anything. Nothing in there yet. And yet they are not showing that they're stuck at all. And this one moved down and just... What the heck? It's as if those steps weren't progressing or something. Okay, this is weird. And the flies move around freely. So that's the thing. Flies move around freely, the other stuff doesn't. So the other option that I can check is that we have the situation that if it's hit, if it's not hit, do one thing. If it's stuck, do other thing. But what if I'm gonna do else? Echo collision data is not stuck. Okay, just as simple as that. Maybe it just misses a bunch of stuff. It's weird. Collision data is not stuck. That's all it is. It thinks it collides with something. But why? Because this means collision data is hit. No. If collision data is cannot be nil because collision data is not a reference object, it's just a normal struct. So it cannot be nil. So that means we do have a hit, but it's not stuck. What on earth are we hitting? Oh, I just figured it out. They hit themselves. Yeah, that's it. I figured it out. Because when trash appears, its initial step is random, just so they kind of have, appear at different stages of the pattern. And when there's this movement pattern to offset, okay? If we have this thing, this to offset, I know control click will work. Won't work. Where do I have it? To offset. It'll be probably in common. To offset for the pattern direction. If it's none, it returns 0, 0. That means that we're basically checking for the collision in the same spot we're already sitting on. And that means the thing collides with itself and gets stuck on the step that moves it nowhere. Ah, there we go. So basically, I need to make a thing that collision data will be if trash data.position. Well, let's actually do it if the step is none, okay? Or no, let's just make it, let's compare positions. If the trash data.position, because if I'll add other possible steps or something, it's gonna freak out and maybe the problem will show up again. Is the same as, or like it's different than new position, then we're gonna check for it. Okay? We're gonna check for it. Else, we're just gonna fabricate one that's, we didn't collide with anything. I hope I can format it this way. Okay, the thing started. And I can eat stuff. Oh, look at this. Things are falling. And the thing with the box is it should be colliding with me. And yeah, the box doesn't collide with me, so it does. Yes. Oof. Okay. One change I'm gonna make is with the frog. Not here. It's probably somewhere here. Constants. Where do I define it? For some reason I defined it here. I'm just gonna make all the needs go down way slower because for testing it's just obnoxious right now. Okay, so now I can move freely. I don't need to worry about eating flies or something. So okay, this moves in a, see? Another. Index 3 is not from 0 to 2. And the same spot, this step just randomly becomes something else. How though? Okay, this problem here is something weird, something that I don't know. Weird. If trash data, I'm gonna add another weird debug. So if the trash data dot step is larger or equal to the thing that we set, I want to just echo. Echo the trash data step is too big. Okay. Oops. Just so that I can have it there because this is weird. And I can probably get rid of the I am stuck, and I can get rid of this one because it doesn't matter anymore. Okay, so that part is fine. I just hope that I can just be here for a while and observe as they go full down and maybe do something. No, another one. I think I will need to finish for today because we didn't get anything about the step being too big. Yet, somehow here it was too big. Dot step. All the locations where I can have dot step, not fly. That's all fly. And of trash, we use it here. We set it here, and we check it here. And this is the only place where we touch step. The movement pattern doesn't change anywhere either. Trash movement patterns is straight up a constant. And as in constant, and nim is a compilation time evaluate value. So this is precompiled basically. Huh. I add this. Like, hey, the problem exists in this spot. I really don't know. This is really strange. Very strange error. It's as if there was some problem with compiler maybe, or I mean with the whole execution or something. See? Again, no problem. Index defect. Somehow this happens. Index 3, not from 0 to 2. And this didn't catch it. But why would from 0 to 2? Yeah, 1 to 3. Yeah, exactly. Because the box is none, south, none. So we have from value 0 to value 3. So echo movement pattern the length. Okay. Length of the pattern. I just want to print them out and see if there's some weird fluctuation or something, because that's like weird. Things are unexplained, unexplainable. 3, 3, 3, 3. That's the length, right? So yeah, 9, 9, 3. Okay, everything's 9 and 3. And the last one was 3. Okay. The last one what we encountered was 3. And that's the length. And we're making sure that's less or equal than this. Come on. Well, step is, and we have the step. Okay. I just can't believe it. Does anybody else usually have those weird bugs that just don't make any sense? Why does the step go 0, 1, 1, and they don't really progress that much? 3 elements. It doesn't make sense. Now I'm checking it every time, and it just... Oh, there we go. And step got into 3 randomly. There's 0, 1, and there are no 2s anywhere. So the steps are getting set. 0, 1, 0, 1, okay. So there's... And this one is up to 7 instead of up to 8. Exactly. So this should work. This works, but randomly out of nowhere, from time to time, it does not. It must be past midnight over there, right? Yes, it's 2:30 a.m. So I need to go to sleep because my wife will be mad at me. But what is this thing? Why is that a problem? So this always shows correct value, but this sometimes is just like, nope. So if we have, so basically I want to add check if trash data.step is equal to movement pattern.length. Okay. That situation, I want to do decrease trash data step and echo decremented step to this. And there's no way it's gonna fix it. There's just no way it's gonna just magically work. It's going up and down. Oh, what do we have here? Well, step is 9. Decremented step to 8. So it happened. And then it didn't happen again. Another one. How does it randomly just... I'm gonna increase twice this time. Doesn't mean that if I'm just gonna do trash data step is increase it by 1. If is larger than this, set to 0. What if this is gonna just fix the problem? Doing it the totally naive way or something. And I'm just gonna increment instead of this because whatever, nim. So let's run it again and see if there is any difference. Because I just can't sleep with this going on. Okay, let's see if we're gonna get more of those weird... Oh, there was that error. What? The thing is that if when, I was thinking like, okay, we are going iterating over a list of elements and then modifying their values, which shouldn't be a big deal. And then while I'm modifying those values, we're iterating over a bunch of other ones. Iterating over them again, which shouldn't be really a problem either. Because we're not, when we call check solid collision or whatever, I'm not modifying the values, I'm just reading. So this is very strange. Very, very, very strange. Because when I go check solid collision. Just go over the checkers and run each checker for the position. So all I'm passing is position. Nothing happens here. No modification to any data. Just create new collision data. And then the checker goes over trash. And the trash collision checker, all it does is takes the position. It iterates over the trash cans and checks their position. No modifying anything, just reading. The same thing here. Unless there's a problem with a for loop, which would be very strange, and I can just do temporary, modification of it for index and from 0 to trash can length. Okay, trash can data is this. If position is, yeah, sure. I just do this, so I can literally come on, uncomment. Well, the only thing I'm commenting out is this. So basically, if we have this, and then if we have, for index trash boxes length, right? I'm just checking. And at the end, return false. If this is gonna change anything, I will be really upset because I don't understand why. Indentation, wait a moment. Oh, leftovers. Huh. We wait around and we still got decremented to step 2 because it was wrong. There's some weird shenanigans going on. And what if I'm gonna do release? Does that make any change, or am I just not even running it as a release? Still happens. But at least that little thingy blocks it from actually breaking something. Weird. I wonder if it's just problem with something else. But you can see that the trash is filling out here and starting to pile up. So the only way I can actually go access water now is here. And I don't have the blocking of the player yet, so that will be the next thing to add. Yeah. And soon enough, the corner will be filled up. And oh, this got stuck here. So normally I shouldn't be able to even access there anymore. Gosh, this looks so ugly. But yeah, the only thing now is to literally go here and add a bunch of ugly if else's. So if pressed key up, if not the same direction, go there. Otherwise, move in that direction. So basically, else if position is not out of bounds, and is solid collision from position dot is hit. So basically, if the hit, oh, not even that, I will need to modify. Frog position plus direction up to offset. Holy macaroni, this is so ugly, but I'm just gonna do it because why the hell not? I want to be done with it. I can refactor it later. And if it's not hit, this will be not direction down, direction up. Wait, this is down, up, down, left. And the last one will be right. And I'm sure the thing that I'm doing right now is just gonna say, you know what? You have 30 syntax errors here. There we go. Is solid collision. Oh, instead of is solid collision, check solid collision. Play again. I should be able to go over flies, right? Okay, this is on me. Doesn't move. I can't move up, but I can move down. And I can move to the right unless it's free. Okay, so no collisions. And I can go down to the pond to refresh. Okay. Cool. Do I know CNC coding? Not a lot. I work a little with G-code when it comes to 3D printing, but not really with CNCs. Although I would love to have a CNC, to be honest. It would be a lot of fun for me. I like fabrication. Okay, we've got this, so I can actually quickly reverse this code that I made here. What was it? Trash collisions, was it? Yeah, I just want this because this looks nicer. And this goes away. And I just have this. Still works the same. We had the step being set like this, which I prefer because, I don't know, it's nicer. Okay. And this thing needs to stay here. Still happening. Weird, weird, weird. Mike Tyler is asking, do you know any streamer that knows about CNC? I'm trying to find one because I'm studying CNC and robotics. I don't know anybody that would be doing lots of CNC coding in that way. There's one YouTuber that I recall he had a live stream about assembling one of the like CNC mills, one of the open source ones. What was he? Nero 3D or something? Let's see if he's here. Yeah. Send you a link. You might check him out, but I don't know if he did any actual G-code writing. Or maybe he's still building it. Don't know. Yeah, you can check out his videos or probably in playlists. Yeah, you'll find. Yeah, Milo. There's a playlist. One of the recent ones, Milo V 1.5. You can try that. Okay, that works. Let me just make sure that still compiles. Okay, still compiles. Good. So let me push the code and gosh, let's make it add trash, rain, and collisions. Okay, because this is a big deal. I push it. So we've got take them up permanently. Yes, make them stop player. Yes. And make players stop them. Yes. So the last two important things to add to this whole system, which unfortunately I won't be implementing today because I need to go to sleep. I have work tomorrow. There's an idea of a lick pull and a kick. So in the game, basically, where to go? Let's start the game. So the whole idea is that your role is to actually push the trash away. Okay, so you would set yourself up somewhere. And let's say I'm waiting for that thingy. I would be able to just either Z with a lick to pull it one tile toward me. Okay. And the other thing would be that if I would position myself backwards to it, I would have, let's say, space, and as a frog, you just push it with your legs off the map, like a few tiles away. So this way you would be able to do things. And I mean, right now, it's just pure chaos. But the idea would be to, because the time moves only when you move. And therefore, it will be a little bit like Crypt of the Necrodancer, where, you need to learn patterns of various objects and whatnot and kind of time it and maybe get more points if you do things in a rhythm. Right now, it's just a large map. Everything is chaos. And CPN is saying it's been 5 hours, so the answer to the question and the title is no. I'd say yes and no, because in theory we had a game for a few hours already, and now we're start getting to the point where things are slowing down and we're just adding more features. But the moment we added the food and the two features that you need to go to the pond, get back to it to re-moisturize, and then have flies flying around that you need to eat and then return to the pond to, not die from dryness, that already made it a game. So in theory, yes, not as much as I wanted. So the rest would probably take up another next stream, but maybe I'm just gonna swap some graphics in the background, in the meantime, and we could continue. Hell yeah. I'm kind of liking the concept, and I would like to add sounds and, basic graphics and actually make it more playable. But hey, we can eat flies. So yeah, definitely that needs to happen. The kick and the pull. So that's that. And Mike Tyler is asking, thank you. Have you heard about Haas Automation Incorporated? Yeah, that's a big company. Although if I will be buying something, I will probably just go for Tormac because they're cheaper and I don't know. They seem a little bit more modern rather than Haas being more conservative. But again, there's no way I'm gonna be owning any machine like that in my life. I very doubt so. All right, so I'm surprised some of the people stayed on Twitch. I don't know. I'm pleasantly surprised. So I want to thank you for watching. I want to thank you, CPN, for hanging out with me, and a bunch of other people on the YouTube side. And hey, if you enjoyed the content, consider liking and subscribing on YouTube, or following on Twitch. On Mondays, I stream something game development related. I mean, for me, it's Monday night. For many people, it's Tuesday morning. On Wednesday, I'm usually doing something web development or something else. Right now, I have a series about the SurrealDB, a multi-model database. And on Fridays, right now, I have series where I'm learning more about the NIM language, going through the NIM language manual, which is starting to get a little bit painful, but I will try to continue with it. So yeah, that's that. And Mike Tyler says, shout out to Sweden. Sure. All right. Thank you for watching. And I wish you a great night or great morning. See you.